the Michigan UP EV Readiness Workshop. I'm Jim Saber. I'm the President and CEO of Next Energy. And on behalf of our sponsor, the Michigan Department of Environment, Great Lakes and Energy, our utility partners, Cloverland Electric, WPPI Energy, UPCO, and Michigan State University, I want to welcome you to this workshop. A couple of things. Well, I'm having a... Okay, sorry, I'm having a little issue with moving the screen here. Webinars are always fun. So a couple of housekeeping items. As we get going, we would ask that all participants stay muted and that speakers and panelists feel free to stay muted when it's not your time to speak, so that we can have as clear of a communication and reception as possible for the speakers. This webinar is being recorded and will be made available upon request via email, and it's also going to be posted to our website, which is www.nextenergy.org. We ask that you submit your questions during the presentations to the Zoom Q&A window throughout the webinar. We will have time at the end of each presentation or panel discussion to answer questions. And if there's any remaining or additional questions, we have dedicated time at the end of the workshop to go over those as well. So, and always please feel free to tag us on social media, which is at NextEnergyMI. Okay, our agenda and goals for the day. We are going to start out this morning with an introduction to EVs and EV charging business models and benefits. And Tim Slusser, our Director of Smart Mobility Initiatives, will provide an overview of what are the new EVs, new EV charging models, business models and things to look at when you are thinking about installing and operating EV charging. Dr. Marinez Gamani from Michigan State University will provide an overview of the state of Michigan EV charging study that they performed and citing locations for EV charging and the impact that that would have on your community. We're going to follow that up with a overview from Eric McDonald, our Director of Testing and Infrastructure Development, to provide information on things that you need to think about and plan for in advance of installing EV charging stations on your properties. After Eric's presentation, we're going to have a short break for about 15 minutes, and we're going to follow that up with a panel discussion, which will be moderated by Tim Slusser with our UP utility partners, UPCO, Cloverland Electric, and WPPI. Julie Stavelin will then provide an overview of the Charge Up Michigan program and how you can participate and leverage the state incentives. And when you registered for this webinar, there was an opportunity in the registration to schedule one-on-one meetings with Next Energy's technical team to review your individual sites and your individual goals and objectives and provide recommendations. We've had a number of people request meetings, but that portal is live through the end of the day. So if you have some thoughts or interest as a result of some of these presentations, please feel free to use that and reach out and schedule a meeting with Next Energy's team. So, okay, now it's moving hopefully good here. So why this webinar now? One is we're going to talk about the Charge Up Michigan program. One of the things about this program is the funds are first come, first serve. And so there's been a number of different sites that have taken advantage of this program, and we want to make sure that communities and businesses in the Upper Peninsula know about this program, have access to thinking about it and plan for it so that we can have a robust statewide network of EV charging stations that will ensure where if we travel across the state. One of the questions that came up in the registration was, are EVs available in the Upper Peninsula? The answer to that is yes. There's a number of different EVs in the marketplace right now that people can buy from General Motors, Tesla, BMW, Nissan, and others that have 200 to 300 mile range. So there are EVs in the market, but more importantly, that is growing. In the next 12 to 18 months, we're going to see a number of new models, new electric SUVs like the Ford Mustang Mach-E, pickup trucks from Ford, General Motors, Rivian, Bollinger, and Lordstown Motors, and also commercial vehicles like the Ford Electric Transit Connect, that can be used for package delivery and local delivery within communities. So we see a number of different models coming out in the marketplace that will have long range and that will support the needs of customers and citizens in your communities. And lastly, when we think about this and when these models will come out in 2021, the time is now to start thinking about this and preparing for this. When you're looking at fast charging and other high power systems and infrastructure, there can be significant lead times, not only for transformers and other equipment, but just utility connections and other things. So if we want to have charging stations operable and in the market in the summer of 2021, we need to start planning and thinking about that now. So a little bit about Next Energy and our role and our work in electric vehicles. For those of you that don't know about Next Energy, we are a Detroit-based nonprofit. We have a number of subject matter experts on EVs and EV charging, and you'll hear from Tim Slusser and Eric McDonald throughout the day. We have developed and operate specialized infrastructure to study EV charging use cases and business models, not only at Next Energy, but at a number of partner locations. And we execute a number of public-private partnerships with state and federal governments to test, validate, and pilot new energy and mobility technologies. So I'm going to talk a little bit about one of the solutions. And through Tim's and Eric's presentations and others throughout the day, you're going to hear about what's currently available with EV charging and how many miles of driving range you can have per hour based on whether it's an AC charger or a DC charger or a fast charger. But one of the projects we're working on right now is what the US Department of Energy refers to as an extreme fast charger. And this is a DC charging system that can charge an electric vehicle in just a matter of minutes. So we can get up to 200 miles of driving range when we're connected for just 10 minutes to this charging station. The charging station is being developed by Delta Electronics. General Motors and DT Energy are also part of this program with the Department of Energy. And right now, this charging station is being tested on Next Energy's campus, where we have worked this summer on the design, development, installation of all the transformers and switch gears and other things to be able to safely commission and operate this charging station. So we have a lot of experience, and primarily you'll hear from Eric later on this morning about things that we had to do and things that you should be thinking about when you are installing charging systems. We also do a lot of work in piloting technologies in Michigan communities. So we are the program manager for the Planet M pilot program. And in this program, we have launched 25 pilots in Michigan communities. Many of these pilots involve new technology, but are electrified and in some cases automated. So our team has a significant amount of experience in helping companies, technology providers, communities, property owners, et cetera, understand what are some of the things that need to be thought about and planned for when installing, commissioning, and permitting and making sure that these systems can be operated safely in public environments. So again, feel free to reach out to our team through the course of the day to schedule meetings with to talk about your individual applications. So with that, I'm going to turn it over to Tim Slusser, our Director of Smart Mobility Initiatives, to talk about EV charging business models and applications. So Tim, I've turned over control for the PowerPoint, so you can take over from here.
All right, so I'm requesting control. Thank you, Jim. Okay, let's test here. Says I am in control. There we go. All right. So thank you, Jim. Good morning, everyone. Welcome to the Michigan UP EV Readiness Workshop. Really excited to be here talking with you today. As Jim mentioned, please, if you have any questions, put them in the Q&A box. We're going to allow the presenters to speak, and then I'll be monitoring the Q&A box throughout the event today. And at the end of presentations, I will be looking in the Q&A box to try and field some of your questions. We might not get to all of them. Know that if we don't get to your questions, we'll try and download those and answer those, potentially put those on our website after the event, things like that. So, but please feel free to use the Q&A box. I'm going to start off this morning, talking about kind of, think of it as like EVs and EV charging 101, right? So we're calling it the EV charging technologies overview. We're going to have, a little bit more technical discussions a little later. And so I just kind of want to make sure that everyone kind of understands when we talk about kilowatts or kilowatt hours or level 2 DC fast charging, what do those things mean? I see we've got a great representation, this morning. So thanks everyone for joining. So as we kind of get this started, I want to level set and say, hey, what is an electric vehicle, right? We're comparing this to a conventional vehicle. When I say electric vehicle, I'm referring to battery electric and plug-in hybrid electric, and a vehicle that can actually travel using only electricity for miles of range, right? So not your traditional hybrid like a normal Toyota Prius or something like that. Something you would actually charge from one of these charging stations. So conventional vehicle, real quick, we should know this. Fossil fuel is the primary source of energy. Gasoline, diesel, internal combustion engine propels the vehicle, right? And then when you do that, you have tailpipe emissions from that combustion. So, this isn't to knock the conventional vehicle. We're just doing a quick comparison here on the major differences. For an electric vehicle, you have a battery on board that stores that electricity. That's the primary source of energy for the vehicle, the primary source of fuel, if you will. And then you have an electric motor that propels the vehicle, right? So when you think about an electric motor, it's far fewer moving parts. It's basically some magnets, some copper wire, and then a couple moving parts versus an internal combustion engine. There's many moving parts inside that. And then finally, the electric vehicle can operate with zero tailpipe emissions for long distances. So again, long distances, I'm talking miles of distance, right? So at a very high level, that's the major differences. What makes an EV so great? I kind of want to talk real quickly about some of the benefits so that we can kind of think about those as we're going through the rest of this presentation and the ones later today. So some of the benefits include lower fuel costs, and I'm actually going to do some math in a little bit. Don't worry, it's not going to be too difficult. We'll all be able to follow along. But the fuel costs for electric vehicle are substantially lower than a conventional vehicle even today. Okay. Lower maintenance costs, right? I mentioned there's less moving parts. Less moving parts generally means, greater reliability. It means less maintenance, those sorts of things. So you have less maintenance on, some of your powertrain. You've got less maintenance on your brakes if you're using regenerative braking, which is a feature for many electric vehicles. So overall, generally there's lower maintenance costs. Greater vehicle performance. So the battery, which is, again, the main source of energy for these vehicles, is put in the floor of the vehicles. What that does is it creates a lower center of gravity, which really helps with vehicle dynamics, better handling, more responsiveness, those sorts of things. And then faster acceleration. So with an electric vehicle, these electric motors, their highest power output is actually right as soon as you turn them on, right? So, from a vehicle perspective, when you're stopped at a stop sign and you first start to accelerate, that's actually when the vehicle makes the most amount of power. So it actually creates a really exciting acceleration dynamic. Ease of recharging. We're going to talk a little bit today about how long it takes to recharge, but the point I want to make here is that it is very easy to recharge. You literally walk over, you plug the vehicle in, and you leave it. That's it, right? Sometimes it takes a while to charge, but the ease of recharging, very, very easy. Local environmental benefits. I talked about those emissions in a conventional vehicle. When you have an electric vehicle and you're operating in electric mode, if that's a plug-in hybrid, right? Then the local environmental benefits is there's no tailpipe emissions. We all I think are aware of what happened back in March, April, May, early on with COVID. There were pictures from all over the world of cities that normally were covered in smog and all these emissions that because of lockdowns had crystal clear skies. And then, as we kind of wrapped back up to try and get back to life as normal, suddenly those smogs and the smog is back and the clear skies are gone, right? So there is a local environmental benefit. we'll need to get to scale in order to fully realize it, but those things are possible. And then in many cases, lower total cost of ownership. And I say lower total cost of ownership because I mentioned lower fuel costs, lower maintenance costs, but these vehicles are more expensive than their conventional counterparts today. Even despite that, in many cases, there's lower total cost of ownership for these vehicles. So we'll talk a little bit more about that too. All right, so now let's talk EV charging basics. So there's kind of 3 of them. All right, level 1, which is your AC standard wall outlet. My computer's plugged into it. Your computers are plugged into it. You're getting somewhere between 1 and 3 kilowatts of output on this, depending on the current rating. So simplification, we're going to say it's about 5 miles of range per hour of charging. So over 10 hours, you're getting a total of 50 miles of range. Not fantastic, maybe doable for some people. It's okay if you have a plug-in hybrid and you're not, beholden to using electric only for transportation, right? You have the option to use gas once in a while, but for most people, this is probably not enough. Then there's level 2, which is also AC. For residential, you're talking, 240 volt outlet. Maybe you've got 30 amp circuit you can hook up to. You got about 7.2 kilowatts of total power output there. That's good for about 20 miles of range per hour, which is actually a fantastic solution if you have access to a garage or access to a place to charge overnight. 10 hours of charging, that's 200 miles of range. So unless you're driving more than 200 miles of range every single day and you need your car in less than 10 hours overnight, this is a fantastic option. And keep in mind that at the end of the day, you're really just kind of topping off your vehicle. This isn't what you do with your conventional, gasoline or diesel powered vehicle today. You don't go to the gas station every single day before bed and just quickly top off your vehicle, but you can do that with an EV. So there's a little bit of a different dynamic here, a little bit of a different paradigm. From a commercial standpoint, we're going to call this around 19-20 kilowatts of capable power, but you're really talking about a 240 volt circuit at 80 amps. So this isn't super common. At least not in a lot of places, but it is accessible. So you could get up to, let's say, 20 kilowatts of power for a commercial setting, which would be about 50 miles of range per hour. So, and that starts to become something that we'd like to see, in terms of EV charging infrastructure out in the public domain, right? Allowing some of this long distance travel. So this is kind of a theme of today. What are we aiming for as a state? What is Eagle aiming for with their plans for statewide infrastructure? We're trying to enable statewide long distance travel. So then the third is DC fast charging. Sometimes it's referred to as level 3, but really it's just called DC fast charging. So most vehicles today are at or below about 150 kilowatts. That number is actually kind of moving up into the 200 range. But the infrastructure that's available today is up to 350 kilowatts. So there's a vehicle in the marketplace. It's a Porsche. That can charge at 350 kW today, but there will be more vehicles in the future, the new ones that are coming out that will start to approach these numbers as well. So we're going to use that 150 kW number for now, and that equates to about 200 miles of range per hour of charging, right? So you're starting to see kind of how this progresses. 200 miles of range per hour is a fantastic number, especially for long distance travel. So let's talk a little bit more about DC fast charging, because that's kind of the intent here. That we're looking at. So DC fast charging, or DCFC as it's sometimes referred to, again, it enables this long distance travel. Power levels range from 25 kW up to 350 kilowatts. And that is what I was able to find as available charging stations that you can purchase today online, right? So I found something as low as a 25 kW, found something as high as a 350 kW. Next Energy, what Jim mentioned, our extreme fast charger is actually a 400 kW system. So that's part of, kind of where this is heading. We're moving a little bit higher in the power infrastructure. I'm going to talk a little bit in a minute about what you need to be aware of and if you're making decisions on what to buy. The main point is you don't need to be worried. Whatever you choose, people will be able to access and use. Infrastructure costs increase as the power level increase. So this is kind of the balance here, right? How much power do I want to bring to the site? How much power do I want to be able to provide to these EVs? And knowing that the more power I provide, the more expensive it is. Okay, so when you try to put that higher power charging station in the ground, you need larger, more expensive equipment to power it. right? Because the station doesn't just plug directly into the utility. There's some transformers and things like that in the middle that allow it to operate at the voltages and things like that that it needs, right? So, and Eric's going to talk a little bit more about some of that too. EV drivers. So this is something I want everyone to kind of be aware of too, as you're looking at DC fast charging. EV drivers generally accept that higher power EV charging, i.e. DC fast charging, is more expensive to purchase than level 2 AC, things that take longer time, right? Lower power levels. So specifically, you know, maybe it's 25 cents per kilowatt for level 2. It might be 50 cents per kilowatt for DC fast charging. So there is a more an opportunity to charge more for these higher power levels. What else you should know? Okay, any car that can charge, that's rated to charge up to 150 kW, can use a 60 kW charging station. So it can use 150 kilowatts or anything less. Okay, so that, you know, the point about accessibility to this infrastructure. Any vehicle that can charge at 60 kilowatts can use a 150 kilowatt charging station. It's just the charging station's only going to output what the vehicle allows, right? The vehicle is going to say, hey, I can't accept 150, I can only accept 60, so please give me 60. And that's what the station will do. So there's this kind of backwards compatibility that I want everyone to be aware of as you're going to choose what type of a charging station you want to deploy. You know, you don't need to be specific. A vehicle that's rated at 150 doesn't only use a 150 charger, right? So, you know, there'd be an opportunity to talk a little bit more specifics about this in the one-on-one sessions if you do choose to sign up for those. Public EV charging can also support local municipal fleets. So I want to make this point, you know, especially up in the Upper Peninsula where maybe the EV demand right now is a little bit lower. Consider if you want to deploy one of these charging stations because you want to take advantage of the state incentives, right? You want to contribute to building out this statewide network. Consider buying an electric vehicle for some of your local municipal fleets, right? That vehicle or vehicles could utilize this charging infrastructure as its, you know, main refueling station, therefore increasing your utilization, you know, your return on investment, so on and so forth, right? So these are ways to try and spread those costs out and to leverage the infrastructure to do more. Some charging infrastructure can advertise for local businesses. So as you start to think about, hey, if I need an hour to put 200 miles of range into my vehicle, what am I going to do for an hour, right? When I go to the gas station, I get 200-300 miles of range in 3 to 5 minutes, right? So this is a different experience. So people that are using this infrastructure, they're going to want to maybe grab lunch. They're going to want to maybe go to your downtown areas. You know, if there's any, you know, business owners that are joining us today, maybe you want those people in your stores, right? Spending money. It's not to say they'll always need an hour to charge, but again, it's going to take longer than what it does to walk into, you know, a 7-Eleven or a convenience store, buy a quick, you know, pop and a bag of chips, and get back in your vehicle. So working, you know, with local businesses for advertising and that sort of things, or where you site this charging infrastructure, can create economic development opportunities. Finally, EV charging stations, the dispenser itself. So the image that you know, Jim showed of the Delta product, that I showed on my slide about the 3 different levels, that station itself lasts about 10 years with maintenance. Okay, that's pretty much on par with the same, you know, expectations for the gas pump that you're used to, right? The balance of plant equipment behind it, the transformers and those sorts of things, those last much longer than 10 years. But that station itself lasts about 10 years. So again, as you start to evaluate this, you know, you can be thinking about those in terms of your cost. EV charging business models. All right, let's do a little bit of math here. So generally speaking, 1 kilowatt hour of electricity equates to about 4 miles of range. All right, this is an approximation based on the number of vehicles that are in the marketplace. It's an average. So think of maybe a small SUV or a mid-sized car. So then I chose Marquette, Michigan. All right, gas in Marquette, Michigan on November 12th, when I did this, you know, put these numbers together, was $2.11 a gallon. Okay, the average residential electric rate in Marquette was 14.7 cents per kilowatt. Okay, And I found these online. I didn't talk to utilities in specific, so please, don't yell at me if you pay something a little bit different. But utilizing those numbers, I chose a vehicle 25 miles per gallon on average. So I'm thinking something like a small crossover here. $2.11 per gallon divided by those 25 miles per gallon get you about 8.4 cents per mile. If I take that and I multiply it by 4, because there's 4 miles per kilowatt hour electricity, the equivalent cost for electricity would be about 34 cents. All right, so if I'm going for 33 to 34 cents down to that 14.7, you can see there's a margin in there to recoup costs, to drive profits, so on and so forth, right? So it's less expensive to utilize electricity. On the flip side, if I want to do the same exact math in the opposite direction, 25 miles per gallon, 14.7 cents per kilowatt hour, again, 4 miles per kilowatt hour electricity. You're talking about, if you charge electricity, you're getting about 92 cents per gallon equivalent in terms of costs, right? So doing math both ways, I'm just trying to show you there's opportunity for cost savings as an EV driver. There's opportunity, for profit, or to recoup your costs in terms of if you're actually the station owner. All right, and as I mentioned, people who are using DC fast charging, they're willing to accept that it's more expensive to charge that way. A little bit more math real quick. I'd be remiss if I didn't try and point this out. Assuming 12,000 miles a year driven for that 25 mile per gallon car, gasoline costs are going to be about $1,000, right? At $2.11 a gallon for the year. Electricity costs at that residential rate is $441 for the year. Okay, so that's a difference of $571 and change. So this is where you start to save money with electric vehicle. That total cost of ownership, right? Here's part of where it is. This is also why EV owners are willing to spend a little bit more money to recharge on DC fast chargers, because they're saving money when they're utilizing their home charging. They're saving money when they're utilizing, some of the lower charging for the majority of their charging, right? So just wanted to point that out. A little bit more about the infrastructure models here and how people are charging. So I utilized Electrify America. They're developing a nationwide infrastructure. It's mostly DC fast charging, so that's why I like this as well. So there's 2 ways that you can charge for the electricity and the access here. In many places now, we have passed laws that allow for you to charge by the kilowatt hour. Prior to those laws, if you ever charged by the kilowatt hour for electricity, you were considered a utility, and then you had to basically go through all the utility, set up a utility business and all this sort of stuff, right? So that's obviously prohibitive for a lot of people and cumbersome. So some laws were passed to allow in certain regions you to charge by the kilowatt hour. So please check with your local utility. We're going to have someone on a panel later today that I'm moderating. In some cases, you might be able to charge by the kilowatt hour. If so, that's fantastic because it allows you to you really kind of control your costs and understand what your revenue versus your costs are. So for example, here, Electrify America is charging 43 cents per kilowatt hour if you aren't a member of their network. If you are, they give you a monthly fee and they charge you a lower rate per kilowatt hour. So i.e. 43 cents per kilowatt hour here. If you cannot charge by the kilowatt hour, what you do is you charge by access and time. So you'll do something like, hey, we're going to charge you $1 to initiate your charging session, and then we're going to charge you 50 cents per minute, or something along those lines, right? That's the other model. So if you're stuck in an area where you can't charge by the kilowatt hour, this is what you'd be looking to do. And really, those numbers are based on your costs, right? So those numbers can vary, and that's okay. So next, a couple other things that I want you to be aware of relative to the business models. Idling fees. So again, because this is not a 3 minutes and done situation, this is maybe 20, 30 minutes, an hour. People are walking away from their vehicles and they're coming back later. Well, sometimes their timelines don't line up perfectly and the vehicle is done charging. Someone else might be waiting. And if you're the station owner, you're potentially losing revenue. So what a lot of station owners have implemented is what's known as an idling fee, okay? And it's really a disincentive to leave your vehicle in the charging station once you've finished charging. So they'll provide something like a 10-minute grace period. And again, this is Electrify America's model here to stay consistent with them. So after a 10-minute grace period, they start charging 40 cents per minute for that vehicle being left there, okay? So this is, again, it's a disincentive to allow there to be more turnover and higher utilization. Advertising revenue, I mentioned a little bit about this. Sometimes there's actually physical signage room on the charging stations, so you can advertise for local businesses. In other cases, sometimes those charging stations are smartphone enabled, right? So you can actually have an application where they're paying. And in that application, you might be able to provide ads for local businesses. You initiate your charging session, and then a coffee shop pops up and says, "Hey, grab a cup of coffee for 50 cents or something like that." So then they can go and actually take advantage of that promotion to a local business once they've initiated their charging. These are additional ways to maybe either drive revenue, drive economic development. Again, try and create a better return on investment for putting that infrastructure in place. With that, I'm done. I don't want to take up too much more time. I see here I'm at 9:30, so I got maybe 1 or 2 minutes for questions before getting into the MSU study. I'm going to take a quick look at the Q&A here. Since multiple, so this one's from Amara. Since multiple companies are developing different EVs and EV charging stations, will they be able to be universal? So for example, could a DC fast charge charge any type of car, or could we be in a situation where each company makes their charger proprietary? So what we're moving towards, and actually Eric a little bit later, I probably should have shown this slide, but he's going to show it, is the different charging connectors. We're moving towards a standard in North America, okay? So there's going to be one connector. It's called the CCS connector. So basically, any charging station you're going to purchase, that's the one you want to ask for. That's what every single vehicle in the US is going to be sold with. So you will have compatibility. There won't be proprietary connectors. Even a Tesla, which has their own network, has a proprietary connector. They sell their vehicles with adapters to hook up to the CCS. So their cars can go off. So the only thing that every other car besides a Tesla can't access is a Tesla network, and that's by design because of Tesla. So yeah, you don't need to worry too much about that. As long as you're getting a CCS connector on your charging station, you should be good to go. All right, and then I'll read one more real quick. What about the state of no plug-in charging, i.e. inductive charging? Is this more than 10 years out? So what we're talking about here is wireless charging. We can just drive your vehicle right over a platform, and then it automatically starts charging for you. This is still in development. They're getting closer, and this is actually being targeted a lot for residential. They think that's maybe like one of the first markets. You pull in your garage, it's clean. You don't have to worry about the snow, the ice, all sorts of things. You can kind of, just park and forget it, and it makes it seamless. That charging infrastructure, is, I don't know if it's 10 years out, but it's certainly not something, that is going to be widespread today. The vehicles themselves don't have the infrastructure built onto them to allow for wireless charging. So it kind of needs to be customized at the moment. I'm sorry I couldn't get to all the questions. Thank you for those that you did submit. We're going to go and let Dr. Gamami get started here. So Dr. Gamami, good to see you again. I'm going to go ahead and relinquish control here so that you get your slide queued up. Don't want to go too far. I hit too many buttons. Sorry, there's your slide. I'm giving up control. So now you can go on and request it and get started. So thank you, Dr. Gamami.
Thank you. Good morning, everyone. I just requested control. Let's see if I have control. I don't think I have. I'm going to request again. I just requested control again.
Yeah, sometimes it takes a second to sync. So I was using up and down arrows on my keyboard. That was the easiest for me.
Okay, it says that you can control. So let's see if it works. Great. Okay, now it works. Good morning, everyone. Thank you, Tim. Very interesting presentation. My name is Mernaz Gamami. I'm an assistant professor here at Michigan State University. And what I'm going to present today are a brief introduction to the charger placement project and the results of charger placement project. This is a joint work with Dr. Zokai and also our research team here at Michigan State University. The study was funded and supported by Michigan Department of Environment, Great Lakes, and Energy. I'm going to start with a brief introduction. I'm going to talk about our problem statement, our modeling framework, and then I'm going to present our numerical results. and how we can use these results. So as of introduction, the charger placement project started about 3 years ago. We started with intercity trips of EV users for phase 1, considering Michigan highways. And then we did an additional supplementary report on tourism analysis. We talked about the tourism attractions and the increased demand for tourism places in Michigan. And it was a huge difference in travel demand between summer and winter. So we included that tourism demand analysis in a supplementary report for intercity trips of EV users. We did also a statewide emission estimation by adoption of light-duty electric vehicles. We then continued our work with phase 2 urban analysis for chargers to support urban trips of EV users. And now we're working on phase 3 with distributed energy resources and energy storage system to support EV charging. And then the next phase is going to be heavy duty vehicles, which might not be a state funded project, but might be funded from somewhere else. We're working on it. And it might be that we can get those results and implement it for Michigan later. So this is the path that we've been taking towards a sustainable transportation system here in Michigan. And when this started, the charger placement project started, it was one of the first among the states in Midwest and even East Coast to do such a study. We have seen people contacting us from utilities and also planning agencies in Midwest and East Coast about the results, the modeling framework, and the approach that we took. So it has been very well received. It's also in line with state goals. Toward building a carbon neutral Michigan, for example, it says Michigan will aim to achieve economy-wide carbon neutrality no later than 2050. Electric vehicles and putting chargers, building chargers for these electric vehicles would be one of the means to get to that goal. And there are other listed statements that well fits with the charger placement project, different phases from phase 1 to phase 3. So problem statement, what was the problem that we were trying to solve with this charger placement project? We wanted to find the optimal infrastructure investment to support electric vehicle travel. We wanted to know where to put these charging stations and how many charging outlets we would need at each charging station. The phase 1 was intercity trips of EV users, phase 2 is urban trips, and phase 3 is storage systems. So for each of these, we wanted to know where to put charging stations, how many chargers are needed. And then for phase 3, we're going to see if storage system is going to help with the analysis. But phase 3 is still ongoing, so I don't have the results for phase 3. But I'm going to mostly talk about intercity trips of EV users today. The modeling framework considers EV trips feasibility. So the main purpose, the main constraint here is to make sure that every single electric vehicle trip here in Michigan is going to be feasible. We want to minimize the charging station investment cost, which includes the cost of charger itself, the cost of acquiring land, if it's any cost of bringing electricity to the land, all those costs are included in the modeling framework. And we have had some great help from our utilities to get those information for most of our locations. We want to also minimize travelers' delay, including charging time and the queuing delay or detour time. Detour means going out of their way to get to a charger. So we want to minimize all those times as well. So we're considering both the investment and also the users. Because if we only consider the investment, we would put too few chargers, and then we wouldn't have users that are happy with the location of chargers or the number of chargers at each location. So this study only focuses on DC fast chargers. We're not talking about level 2 chargers in this study. And it is to support long distance trips of EV users for this study that I'm going to talk about the results. The results that I'm going to present includes partial tourism data, but it doesn't include the full tourism data. So for some of the location, it has a little bit of tourism data, but which were for the crucial points, but it doesn't have the full tourism analysis. Full tourism analysis results are available in the supplementary report, which is on Eagle's website. So here's our reference network. It's a sketch network of Michigan that has major cities, interstate highways, as the focus of the study is intercity travel. So we have the travel demand around major cities and aggregated. We have that travel demand aggregated to city centers. We didn't delete any of the demand. So if we see, for example, one node in Lansing, it doesn't mean that it's only the demand at that point. It's the entire demand for Lansing to travel for intercity travel. But we aggregated all that demand to that one point. And then the only demand that was excluded is the demand that travels within the city, urban demand. And that urban travel was addressed in phase 2. The distance, so each node represents either one of the interchanges or interchanges on highways or exits, major exits on highways. And the candidate points, so those black dots are candidate points for building charging stations. And candidate points are located in a way that the distance between any two candidate points is less than 50 miles, which means that if there's a user between any of those two candidate points, the distance between the next candidate point, between the user and the next or previous candidate point is less than 25 miles. So these are the candidate points. It doesn't mean that we're necessarily going to have charging stations at each of these locations. And we're going to get to the slide that shows where the charging stations ultimately get located at. But these candidate points means that we're going to see whether we need to build a charging station at either of these candidate points or not. So it might get selected or it might not. For demand analysis, we have the travel demand from Michigan Department of Transportation. The travel demand that we do have from Michigan Department of Transportation, it's based on their survey, and also we got the data from continuous counting stations that are located on Michigan highways that are collecting data 24/7. So those are the two sources of travel data that we got from Michigan. And then we needed to know how EVs would travel, how many EVs we're going to have, or what would be the prediction. So for that, we're using MISO scenarios. For 2020, they say that it's going to be 1.49, for 2025, 3.75, and for 2030, 6%. So that's the number we use, the 6% for 2030. We are adopting MISO's scenario for EV market share. We later did some more analysis with higher market shares as well. But the results I'm going to present today and the results that are available in the report are based on 6% market share. So here's demand variation over different months, and this is travel demand. So what we noticed is that in Michigan, and it's kind of intuitive that we all know that travel demand in Michigan varies, the intercity travel demand varies significantly between winter and summer. As you can see, for example, the travel demand in January, February, and December is much lower than that of June, July, and August. So the travel demand, and it's in million vehicles, the travel demand drops significantly during winter time, or we can say it increases significantly during summertime. So that's something that we had to consider in our study with the monthly variation of demand. So we did the analysis using the continuous counting station located on Michigan highways that are collecting data 24/7. So we got that data and use that data to do the monthly variation scenario analysis. For this study, we considered different scenarios. We have two seasonal scenarios and also demand and battery performance variations. So we have summer scenario, which we are considering the summer demand, June and July demand, with 100% battery performance. And then we have winter scenario, which is January, February demand with 70% battery performance. Why did we consider the drop in battery performance? Is that electric vehicles range drops down to 70%. And we got these numbers by during the meeting that we had with OEM car companies. So the winter battery performance drops to 70%, but the demand also drops in winter. We also consider two types of batteries based on the discussions that we had with car companies, 70 kilowatt hour battery and 100 kilowatt hour battery. And then we considered three rates of market growth for different years. We did analysis for 2020, 2025, and 2030. The results I'm going to present today are the results for year 2030. And we considered two DC fast charger options, 50 kilowatt charger and 150 kilowatt charger. And we later did also analysis for 350 kilowatt charger. But the results, I'm not going to present the results today, but I'm going to present the results for 50 kilowatt and 150 kilowatt charger. Again, more detailed results are available in the report that is on Eagle's website. But here are the scenarios that we tested. A lot of combinations. So for summer, considering, for example, considering one season, one battery type, 1 year, and one charger. And then all these combinations, we tested all of these combinations. And I'm going to talk about the results now for all these scenarios. So something that we did was comparing winter versus summer. So on the left-hand side and on figure A, we have charger placement to support winter travel demand and battery performance. And on the right-hand side, we have charger placement to support summer travel demand and battery performance. As I mentioned before, we noticed that the travel demand is way more in summer, but also battery performance is better in summer. So battery performance drops down to 70%. So if you take a look at these figures, each red dot represents a location that was selected to build charging stations. So it's each red dot represents a location that was selected to build charging station, but the size of the red dot represents the number of chargers at that location. So the bigger the red dot means more chargers is needed at that location. Comparing the left-hand side and right-hand side figure, we can see that during summer, we need a lot less chargers, even though summer travel demand is way higher compared to winter travel demand, but the 70% battery performance during winter time means that we would need a lot more batteries to support winter travel demand because the performance of the battery drops. It means that the battery is going to get depleted faster. It's not going to have as much range as it does have in summer, so we would need a lot more chargers to support intercity trips during winter time. So even though the demand is lower, we would need more chargers to support the dropped performance of batteries in winter time. Another analysis that we did is the table that we see underneath the two figures. Each row has number of charging is the number of stations, then the next one is number of charging outlets, the total delay, and the total cost. So the first column is optimal solution for winter battery performance and demand. The next one is summer demand allocation to the optimal solution for winter, and then the last one is optimal solution for summer battery performance. So the two columns on the two sides is winter scenario and summer scenario. But in the middle, we are considering what happens if we have the summer charging stations, the winter charging stations. So we built the network for winter because we need a lot more chargers, but we put summer demand in it. How would things change? And we see that, for example, some of the locations that are not selected in the winter scenario, but are selected in the summer scenario. For example, that node right of, if you look at Traverse City, not the node exactly on Traverse City, but there's a node to the right-hand side that is not selected in the winter scenario, which is the left-hand side picture, but that node is selected in the summer scenario. So if you build for winter, to support winter, which needs a lot more chargers and charging stations, we're not going to have that node there. That's an example. There are a few more nodes like that. But what will happen? Would the trips be feasible still during summer? And that's what we looked into. And we noticed that the trips are going to be feasible. If we build the network on the left-hand side, we can support the summer trips. But what will happen is what we can see in this table, that on the third row of the table that says total delay, if we build for the winter scenario, the total delay is going to be 3,000 hours, but that delay is less if we build it specifically for summer scenario. So if we build for the winter scenario, we notice that the trips is still going to be feasible, but the delay, the user delay, and it's mostly the detour delay of the users, is going to increase by a small portion. So the best approach would be to build for winter scenario, and that those chargers would be able to support the summer demand. It's a slight increase in detour delay. But if you build for summer scenario, those chargers are not going to be able to support winter's reduced battery performance. So among the scenarios that we did, we decided that some of the combinations were more interesting to talk about them in more details. we have 70 kilowatt hour battery performance, 70 kilowatt hour battery, and 100 kilowatt hour battery. And then we have 50 kilowatt charger and 150 kilowatt charger. So combining the small battery and slower charger, which would be 70 kilowatt hour battery and 50 kilowatt charger, which is, we can see it under assumptions here, would give us our low-tech scenario. This is what we call the low-tech scenario. And if you go through report, you can see that this is our low-tech scenario, 70 kilowatt hour battery and 50 kilowatt charger. And I'm presenting the results for winter because, as I talked about it, if we build chargers to support winter's reduced battery performance, it's going to work for summer as well. So if we look at this low-tech scenario, we can see that the total number of stations is going to be 43 stations in Michigan, with a total of about 598 charging outlets that are required. Something that we did for this study is that we are assuming that we have at least 2 chargers at each location for redundancy purposes. And building this network would have a total cost of $28 million. The station investment cost is 6.6, the land investment cost is 1.1 million, and the charger cost would be $20 million. And the total refueling time and the average delay, it's about 30 minutes are reported as well. That's average charging and detour delay. So those are the results for the low-tech scenario, 70 kilowatt hour battery and 50 kilowatt charger. But if we have a better battery and a higher power charger, what will happen? This is what we call our high-tech scenario. It's 100 kilowatt hour battery and 150 kilowatt charger, again listed under assumption. This is for, again, winter demand. We can see that comparing to the previous one, we need a lot less chargers. Again, each red dot in this figure also represents a location that needs charging a station, and the size of the red dot represents the number of chargers at that location. So we need a lot less chargers if we have a 100 kilowatt hour battery and 150 kilowatt charger. There are 2 reasons. First of all, 100 kilowatt hour battery can travel a longer distance. And also 150 kilowatt charger has a higher throughput. So the vehicles would come in, charge faster and leave. And we can see that the average delay from 30.67 minutes in the previous slide dropped to 12.38 minutes in this slide. The number of charging stations is 24 stations, and the number of charging outlets has dropped significantly to 128 from the 600 in the previous scenario, from the low-tech scenario. We noticed that 150 kilowatt chargers, even though they're more expensive for each charger, overall, as we need less chargers, less 150 kilowatt chargers, the total investment cost would be smaller. And this is not comparing the results of 150 kilowatt hour battery and 70 kilowatt hour battery. We compared the same type of battery, but with lower level charger and lower power charger and higher power charger. And we noticed that even though the chargers are more expensive per piece, but we need a lot less chargers, so it would be a total less cost of building these chargers. But the current problem is that some of the EVs that are older EVs, they cannot accept those chargers. So we kept both results in our analysis. And the only thing, if you build 150 kilowatt chargers, is that the EVs would come in and they can only take 50 kilowatt out of that charger. So it would increase the delay in the system. So it would be the charging delay would increase, and also the waiting time delay. So if, for example, someone pulls into a charger with a 150 kilowatt, but they can only take 50 out of it, they would be staying in that charger for a longer period of time. So it means that the next user coming in would be waiting. So the last slide that I have for today is how to use these results for building charging stations. Again, the reports are available on Eagle's website, but our general recommendation is to start constructing in increments while tracking usage at each location. So what we did for this study, we considered uniform distribution of demand. So we assumed that EVs would be adopted uniformly throughout the state. 6% would be uniformly distributed all over the state. And this was for equity purposes. We got the comments during the earlier parts of the study that this is not the case. There are some counties that do have currently more EVs and some counties that do not, but this was not, but for equity purposes, we assume a uniform distribution of demand. So we recommend building in increments and tracking usage to see if more EVs are adopted at those locations. Are the chargers are being built, the chargers that are built are being used or not. So we don't recommend building 20 chargers at one location and waiting to see if those chargers are being used. And then the charging stations, when we say that we need a charging station at this location, we don't mean that at that specific location, we mean within a 5-mile radius of that location for interchanges and for highway exit, 5 miles up and down of that exit. So that gives us flexibility to build chargers that are closer to amenities. So for example, if there's a charger that is closer to Starbucks or somewhere people can get lunch or things like that, that would be helpful. And also we're recommending, so that 5-mile radius would give us that flexibility to select locations that we have site hosts that are interested and things like that to build those chargers. And we're recommending to build at least 2 chargers at each location for redundancy purposes. So if one charger is out, we would have another charger that is working. So that's all I have today. Thank you all for listening. I think I should go to Q&A, right?
Yes. So I'll kind of guide the Q&A here. We've got some questions that came in. So the first one that I want to touch base with you. So you did mention that the report is available. The full report is available on Eagle's website. So obviously there's a lot of things on Eagle's website. Is there like some keywords that you can offer up to the audience so when they go and look for this, they can find it more easily?
Maybe I can just send the link in the chat box here. After I'm done with answering the questions, I can find the report and send the link here in the chat box.
Perfect. I think that'd be great. So, all right. The next question here says, the study seemed to kind of not include the Tesla charging stations. Can you kind of explain why that was the case?
We didn't, at the time that we started, we looked into the currently available chargers at each location to see if there are any. And at the time that we started the study, there were no public charging stations except for Tesla chargers. And as these Tesla chargers can only support Tesla vehicles, we decided to exclude them from our study to make sure that we build a network of charging stations that can support all the EVs, not just Tesla vehicles. So if we consider that this location has a Tesla charger and we consider it as an EV charger, another type of EV that would get that to that location cannot charge. So that makes that EV trip infeasible. So we decided not to include Tesla chargers in our study.
Yeah, so for today at least, Tesla's charging network is only accessible by Tesla vehicles. And so obviously, the intent here, as I understand it, was to try and create something that could be used for all EVs and EV drivers in the state of Michigan, right?
Exactly.
So, okay. So another question, is battery performance drop in winter only due to cold weather temperatures? And does that result in maybe lower battery kinetics, reaction kinetics? Or is it due to vehicle performance? So kind of what's driving that drop from 100% to 70% in capacity for the battery during the winter months?
So I'm not a mechanical engineer. I'm a civil and environmental engineer with my specific field of research being in transportation. And I might not be able to answer questions specifically about drivetrain of the vehicles, but generally what we got from car companies was that the battery performance drops down to 70%. It means that if a vehicle has a range of 100 miles, that range during winter time would be 70 miles. So that's what we're assuming for our study, that the vehicle cannot travel 100 miles. But the main reason behind it can be running the heating system. There were a lot of different things that they mentioned. It was running the heating system. The battery performance just drops because of the cold temperature doesn't allow the battery to perform as well. So there were a lot of different things, but it's out of my field of expertise. That's the number we got from car companies.
So it is a good estimate. So that actually does happen to be a part of my area of expertise. You're absolutely right. So that the heating is one element, and the heater takes up a good amount of energy in the vehicle. Actually, the air is more dense in the winter months, right? Colder air, the particles are closer together. So it actually, creates more rolling resistance and wind resistance for the vehicle. So those are some of the factors that are contributing to this as well, right? And then actually the battery itself, it's not that it can hold less energy in colder months. It is a little bit of those kind of reaction kinetics that were mentioned in the question. So the automakers like to try to protect the battery, right? So it lasts a longer time. You don't want it to try and perform outside of something of a safe condition. So there's a little bit of constriction in the controls that allow the vehicle to last for a long time. So those are some of the factors that go into that. Let's see here. Answered that one. Okay, so I'm going to go ahead and give you a couple questions that I have here. So you mentioned redundancy, right? Two charging stations, and that being important. Is this happening a lot today, where people will go to a charging station and one of them's not working, or why is that redundancy so important?
So exactly, it's for the purpose of if one vehicle goes to a location and there's that charger is not working, it means for EVs, it's not like there are a lot more chargers at that location. It's not like gas station that this one is out, so I'm going to go right across the street. So we need to at least have two chargers, that if one is out, we would have another one to make sure that EV trips would be feasible. So it's if one charger is out, we would have another one. And there were only a few locations that required only one charger, and we increased that to two. But those were only a few locations. Most of the locations required more than one charger per location.
Okay. So you mentioned that 5 miles is a good reference for how far to space, these charging stations out. Why is that 5 miles a good number for right now?
So what we did for our analysis is based on the traffic analysis zones data for travel demand. And what we considered is that if we build chargers within that 5 mile radius, considering the current range of electric vehicles, that 5 mile radius would still make the trips of EV users feasible. And we have considered that 5 mile in our study. So from the beginning, we didn't want to say that specific latitude, longitude, because we knew that there might not be interest from site hosts at one specific location. So giving it a flexibility of a 5 mile radius, which would still make the EV trips feasible, would help with building these chargers later. So we wanted to give it a flexibility. And the 5 mile radius is a small percentage of current EVs range. So it was good enough to make sure that EV trips are feasible. And also we are not sacrificing a lot of the range of the vehicle.
Excellent. So based on your analysis, because obviously you did a good portion of this analysis up in the UP, right? Looking at those cities and areas, and that's what we're here to talk about primarily. Obviously, we've got some participants that are not from the UP, and thank you for joining. But part of what we really wanted to dive into here was the UP. So based on your analysis, what were some of the most critical areas in the UP to install charging infrastructure?
So if I can go back. So we can see that lower corridor in UP requires a lot of charges. And we noticed that there's a lot of travel, and we considered the out of state travel demand when we were working on this project. So there's a lot of travel demand from Canada and also from Wisconsin, to and from Wisconsin and to and from Canada that uses that corridor, in addition to within Michigan travel demand. So that lower corridor is a very critical corridor here in Michigan to be considered in UP. And the results for UP are also available separately in the study based on latitude, longitude, specifically for UP based on the name of the cities and latitude, longitude of these nodes. So if we look at this study, there are sections that says, for example, these are the nodes that are for these cities, and these cities are located in UP with their latitude, longitude. So that lower corridor, we noticed that even though it was a shock to a lot of the people who were attending the presentation at the beginning, but that's a very important corridor in UP, that lower corridor that passes through, I think it's Escabana, that requires a lot of chargers.
All right, so I'm reading through the Q&A box here. I see a Sunny Stretch rest area would be a great location. So that's been called out. So thank you, Darren. And then, maybe you even have a little bit of insight to this, Dr. Gawami. I know that Eagle is different than MDOT, and to my understanding is that MDOT will manages our rest stops. But there's a question that's being asked: will Michigan be installing infrastructure at highway rest stops? So have you heard anything from the state of Michigan at all about what they're targeting for those rest stops?
I had meetings with one of our state representatives talking about this, and also there were talks about the regulations and things that we cannot sell utility on rest stops. So that's the political part or the regulation part of it that I'm not sure, but people were trying to find a way to install charging stations at rest stops, but there were some legislation issues that they were dealing with. So at this point, I'm not sure what's the result, but there has been talks about installing chargers at rest stops, but neither of these locations include actual rest stops.
Yeah, and actually that coincides with what Next Energy's been hearing too. We've had a few discussions with MDOT. They're very interested in getting EV charging infrastructure at rest stops, but they're kind of in that situation, kind of like you described, where they're working through some political things, they're working through some legislation that exists. They don't intend, as far as I know, to own and operate, right? So then they would need to kind of figure out how do they bring someone in, to provide access to those sorts of things. So, so that's something that's being talked through, right? It's definitely an interest right now. And Darren here is mentioning many rest stops are not near heavy electrical infrastructure. That's a great point. Actually, I'm going to let Eric, my colleague, Eric McDonald, talk about this in his presentation as well. So, we'll go ahead and stop there unless you have any closing comments, Dr. Gawami.
And nothing else from my side, but I can see that in the chat box that someone already posted the link to the study. So if you're interested, it's already posted in the chat box.
Yep, that looks like it was from Julie. So thank you, Julie, for getting that out there for everyone. So,
Thank you.
Okay, all right. So thank you, Dr. Gawami. We're going to go ahead and move on now to Eric McDonald. So Dr. Gawami, if you would please relinquish command under that view options. You can drop control of the screen.
I think I just did. Yeah.
Okay.
Thank you, everyone.
Right. And then Eric, you go ahead and request control, please. All right, Eric, can you hear us?
Yes, I can. Can you hear me?
All right. Yep, we can hear you loud and clear.
Okay, great.
So, all right. So as we wait for the system, obviously, to sync up here and give you control. So Eric is our director of testing and infrastructure development at Next Energy. He's got our numbers, decades of experience in construction and infrastructure. So anything that we're doing on site, the 400 kW system, Eric has been responsible for guiding us on the infrastructure deployments there, making sure everything is safe, making sure everything is set up appropriately. So Eric, do you have control of the system now?
Not yet. Oh, there it is, I think. Yes.
Okay, slides are moving. So. All right, I'm going to go ahead and mute myself and turn my video off so everyone can focus on you. And Eric, go ahead and take it away. Thank you.
Okay, thank you, Tim. Thank you, Dr. Gawami. That was great information. Hope everybody was taking notes because that information will probably come in handy later. So I'm going to give a talk on what you need to know before you break ground. There's a lot of things that happen in an e-construction project. An electric vehicle charger installation is no different. Okay, just check to make sure I'm going. Okay, so the first thing you want to know when you're breaking ground, when you're doing electric vehicle installation, is at what speed do you want to charge? Level 1, level 2, or DC fast charging? Right now I put down no at level 1 because that's normal 120 volt charging using a standard 120 volt outlet. You need no assistance here. A cord is likely supplied with your vehicle, and you just plug it into your 120 volt outlet. With level 2 charging, in 1 hour, your vehicle will receive enough charge to travel 20 to 50 miles. And the next level of charging is DC fast charging. Technically, there is no level 3 AC charging, but many people term DC fast charging level 3. So just know that when you're having a conversation with installers or engineers. Before you break ground, you definitely should have a handle on the workings of your locality. You should know how your government can impact your installation. Know what real estate policies can impact the installation as well. Zoning may allow or it might prohibit access to electrical infrastructure, such as transformers, inverters, cable heights, connections, and etc. Zoning may also prohibit sales if you plan to bill users for EV charging. And sales at certain days and times might be restricted, and they might be considered a nuisance. At your building department, an electrical permit will be required. Do not try to avoid it. Check your distance to property lines, and don't try to relegate the charger to the edge of your property. Building codes say that structures within 5 feet of a property line require fire separation or fire ratings. The concrete pad or the electric vehicle charger could possibly be considered a structure. So check with your building department first. Also, if you place your electric vehicle charger at the outside of your property, you have to take into account ADA requirements. Yes, the American with Disabilities Act will require that you have equal access to parking facilities. So if you have a parking spot for an electric vehicle, it needs to be provided to persons with disability as well. Many building departments are going to require that your drawings be stamped by an engineer and architect. So keep that in mind as you're working as well. Real estate. Real estate may carry restrictions such as sales on site, covenants against commercial enterprise, and lastly, be sure to check with Ms. Big. If your existing underground may show that the further underground construction may be cost prohibitive on site. So check where your underground utilities are before you even plan to install. Determine the ownership of your EV charger. I have up there EVSE. That EVSE stands for Electric Vehicle Service Equipment, or it's also sometimes called Electric Vehicle Supply Equipment. I'll try not to interchange between that and EV charger, but I probably will. So just be aware of that, as well as in language with installers and engineers. They would probably also go back and forth between EVSE and EV charger. So you need to know whether your charger will be owned by the city, the utility, or a private owner. Ownership can have different implications. Will the EVSE be leased to an operator? And if so, you need to work on legal documents. It should spell out who's responsible for operation and maintenance, and how much and how long are the lease payments. Operation and maintenance definition is very important. EV chargers, which especially networked and DC fast chargers, are chock full of power electronics. If you lease the EV charger, you do not want to have the maintenance of the power electronics. Your staff electrician will not likely handle power electronics maintenance. How will your electric bills be handled? Will the charger be metered separately, or do you receive a new service drop? Or will the charges be rolled into the existing electrical bill? If the charge is not separated, how will you determine the lessee's billing? It's better, whether leased or owned, to have a separate meter for the EVSE. This will give you a handle on the amount of electricity used by that EVSE. And with increased use of power on your site, it would be very easy, especially with DC fast charging, for you to incur a large demand charge for your increased power use. Before you break ground, you want to know about your siting. Know where you want to place the EVSE. Level 2 chargers can be mounted on a wall, or they can be standalone. DC fast chargers, for the most part, will be standalone. Wall-mounted chargers are going to incur the least costs for labor and material. But the further the EVSE is placed from your electrical source, the more expensive the cost will be for trenching and wiring. So if you look at these two pictures, try and see what is the problem or what's wrong with this picture. In this picture, you notice they have a curb which stops your vehicle from running into the EV charger. For some reason, this person has a standalone EV charger with no bollards, no curbs, nothing stopping you from running it over. This is an expensive piece of equipment, and you don't want to run it over or knock it over. As well, the distance from the garage, which the electrical source is likely to come from, it would have cost you less money to place the charger over here, especially when you think of trenching for electrical work is usually going to run you about $200 a lineal foot. Be sure you look into your electrical requirements. Level 2 charging can be delivered at up to 19 kilowatts and 40 amps, 80 amps, excuse me. Level 2 charging is accomplished via 240 volt AC. You'll need at least 2 breakers and a 120 volt panel. DC fast charging will require more planning and more equipment, and not all electricians will be interested in doing DC work. DC fast charging can be delivered at 350 kilowatts, 400 amps. An inverter will be required to invert the AC power to DC power. In this slide, look at the differences between level 2 chargers and DC fast chargers. A DC fast charger has an inverter inside it, or it might be separate. And probably there's a series of programmable logic controllers, contactors, relays, and there may be a transformer next to it, as this one has a transformer. When contracting for a DC fast charger, it's best to buy one self-contained unit. You want to buy just a black box, and that black box will contain the inverter. You don't want to buy a DC fast charger which has a separate inverter, because this will add to the equipment cost of having 2 separate pieces, and it will also add to your maintenance costs down the road. When your chargers are delivered, take note of the plug-in connectors. Level 2 connectors will come with one style, the J1772 charger on the left. This is from a Society of Automotive Engineers J1772 standard. So if you have level 2 charger, this is what it's going to be, because they're all standard. DC fast chargers are delivered by these connectors. CHAdeMO is a standard connector developed by Japanese Automotive Research Institute, and it's championed by Japanese OEMs. The CCS, which is the combined charging system, is a J1770 configuration, as is this one, with 2 DC contacts added, which delivers the high-powered DC charging. And then there's the Tesla connector, which is proprietary to Tesla vehicles. So be aware of these different types of connectors when you receive your vehicle or when you receive your charger on site. You should decide whether you want your EVSEs to be networked. Single EVSEs can be networked and multiple EVSEs can be networked alone, or more logically, they can be networked together. The advantages of being networked are you have remote access or control to the charging sessions. You can have possible multiple forms of payments, such as credit cards, PayPal, other forms of payment. Then there's load balancing. It's very important if you have multiple chargers on site to have load balancing, because it will allow you to limit the charge. For instance, if you had 5 vehicles charging at the same time at 50 kilowatts versus those same 5 vehicles at a maximum of 350 kilowatts, you can see the difference. You could have 250 kilowatts charging at once or 1,750 kilowatts charging at once. This will have repercussions on the power delivered to your site, including the load capacity and demand charges. Networked EVSEs will also allow you to control your charging times. This is instrumental in being billed for peak and off-peak charging. It can also make it possible for you to participate in demand response programs with the utility. So from the previous slide, as you notice, you need to know your site electric load capacity. It's probably noted on your electric bill, but you should contact your account manager at the utility to verify. In fact, it's probably best that you contact your account manager to know if the utility has capacity to support EV charging on your site. Your site capacity of electricity is going to limit the number of stations. The number of stations, of course, affects the cost. And not just in installation, but also in the demand charges. As noted earlier, adding 1 or more EVSEs should cause one to consider whether you should add a separate service drop for the EVSEs or connect to the existing service. But many utilities would likely prefer that separate service be installed as it allows the utility to better plan and manage its power grid. And be aware of your demand charges, because some accounts will add a ratchet fee for surpassing your expected kilowatt demand. And then that charge will be added to your bill for the next 11 months or until you meet a new peak kilowatt demand. So look forward in your growth and anticipate your site's EV growth. All auto companies are expected to increase the amount of EV offerings they have. Bloomberg foresees that 28% of vehicles will be electric in the year 2030, and 58% of vehicles will be electric in 2040. You should look forward to an increase of DC power on your site. Renewables are coming. Black & Veatch, the engineering firm, in its 2019 strategic directions, notes that 44% of power industry leaders say that renewables and distributed generation are forcing them to consider whether or not they'll be retiring their generation sites. That's a study from Black & Veatch, which is one of the largest electrical engineering firms in the country. So keep that in mind. DC and different renewables are coming to your electric grid. So what are your plans for solar on your site? If your DC is generated on site, it could be possible to provide some of the power to your electric vehicle chargers. Even better, if you were to add battery storage on site to capture your DC power, it could then be distributed at other times. EV fleets will likely increase in the future. You should work with your finance departments to know what they will fund and know the range for your electric vehicles. You want to eliminate range anxiety within your territory. Better yet, if sufficient EVSEs are installed around your territory, then there will be no range anxiety. Bloomberg also notes that there will be 500 EV models available by the year 2022. That's 2 years from now. So if you are planning on installing EVSEs for your work site, find out the commuting distance of your staff. You could determine how many EVSEs are needed by taking into account the load balancing and limiting charging times, depending on the charging capability of your EFEs. Also, I failed to put it in my slides, but when you are installing networked EVSEs, make sure you check on the software requirements. It is best to try and get your vehicle EV chargers OCPP compliant. And you should write that down. Open Charge Point Protocol, OCPP. If your EV charger is not OCPP compliant, you will more than likely have not problems, but you will be paying more for integration of your electric vehicle charger to your entire electrical system and networking system. So thank you for your time, and I hope you gained a little information from my presentation.
All right, thank you, Eric. We got time for a few questions here. So I'm going to kind of go to the chat or sorry, Q&A box here first. So a comment was made earlier. Many rest stops are not near heavy electric infrastructure, right? Why is that important to consider? If we're talking about a rest stop there, but if your site you're looking at is not near some of this heavy electrical infrastructure, why does that matter?
If you are doing DC fast charging, you're going to need to use a lot of power. You will more than likely need an upgrade to your facility. Most commercial facilities will have 480 volt power at the most. DC fast charging is going to require at least 480. The higher the voltage that you do charge at, then the smaller the cables that you will need to install. So that would be the main reason for upgrades is to make sure that you are able to charge the vehicles as fast as you want. Level 2 is not going to be a problem for most facilities, but DC fast charging will more than likely require upgrades if you do not have 480 volt power.
Okay. A question, about, you mentioned a little bit about connectivity, OCPP, right? What type of internet connectivity is required for the charging stations?
It could be Wi-Fi, or it could be DSL. It's going to be whatever communications that you usually have for a computer. So whatever communication you need for your laptop to your network, or your desktop computer to your network, is what you will need for your electric vehicle chargers. But like I say, you should make it Open Charge Point Protocol compliant, and that way it's going to be a much easier installation.
Yeah, and then a comment was made here. Does the internet on the internet connectivity side, are we talking like gigabit internet, or like what do we need? Is slow internet acceptable? How much bandwidth are we talking here?
I don't know the answer to that. You're going to need to refer that to the IT people. But when you are doing a DC fast charging installation or even a networked installation, like you said, you should be working with electrical engineers and networking engineers who are going to be able to give you the requirements that you need for that. Also, charger manufacturers are going to tell you in their literature what you need to make their equipment work at its optimum.
And Eric, this is Jim. And in many cases, the charging manufacturers that have network chargers will also provide a cellular connection so that you're able to communicate availability, pricing, different signals back to the users and the utility via cellular as well. So it's not necessary that you have like a gigabit connection. There's multiple pathways to communicate to the charging stations.
Yep. So the main takeaway is that there are options in the marketplace, right? They've thought about these things. So let's see how long this question takes. So how much does it typically cost to install an EV charging station? And furthermore, what has the greatest impact on price, in your opinion?
The cost for level 2 residential charging, first I'll give an average of what it is. Residential level 2 charging is going to cost about $130 per kilowatt installed. Level 2 commercial will be about $400 per kilowatt installed. The same with DC fast charging, it will run from, now those are average prices on the lower end. For DC fast charging will also be about $400 per kilowatt. So when you're talking about level 2 commercial charger will be anywhere from $2,000 up to $10,000. A DC fast charger installation could be anywhere from $15,000 to over $100,000. Now, of course, that's going to also depend on what voltage you have available at the site and whether or not you're working with a 7.2 kilowatt charger on the level 2 end or a 400 kilowatt charger on the DC fast charging end. What's going to be the major parts of your installation costs are soft costs, actually. It's been found that soft costs are about 2/3 to 3/4 of the cost of an installation. When I say soft costs, that would be your engineering costs, property procurement costs, dealing with your permitting authority. All those things drive up the cost because it is a construction project, though it is more expensive than a construction project. This is a newer technology, and your building departments may not be used to working with this type of electrical. And so they're going to be very, very diligent in what they do in their reviews of the process. So the planning is going to get into that, the building is going to get into it, the zoning is, they're going to do a lot of fine-tooth combing of your application. But yeah, the soft costs are going to cost the most for your project.
Okay. So I did get a notification from one of our other colleagues that's kind of our IoT expert. When we were talking about the data, bandwidth for EV charging station, we're talking about kilobits. We're talking very, very low end, small bandwidth requirements. So, just to kind of throw that out there as well. One last question. Should be a quick one to answer because we're right up against our break here. When it comes to, but I think very relevant, when it comes to weather conditions, right? Obviously, we're talking about the UP here. We know that there's snow, there's rain, there's harsh weather conditions. What do people need to know about these charging stations and how they're built? Are they built to withstand, those weather conditions?
Yes, the charging stations are built for exterior use. They're going to use NEMA exterior use components, so everything should be exterior grade. Now, they do have level 2 chargers, which are made for interior use, but you need to make sure when you're talking to your electrician and engineer that if you're going outside, it needs to be NEMA rated for exterior use, not interior use.
Okay, and NEMA is spelled NEMA, correct?
Right, the National Electrical Manufacturers Association.
All right. Well, with that, we'll stop here because I want to make sure everyone gets some time to stand up, stretch their legs, use the bathroom if you need to. So we're going to take a break. We're going to come back in about 10 minutes. So thanks, everyone. And Eric, make sure you relinquish control. And then I think Angela can put us on our time slide there. So see everybody back in about 10 minutes, around 10:45. right, we're going to give it just a couple more minutes here, and we're going to get started around 10:50 with the UP panel session. So just a couple more minutes. All right. Thanks everyone for being patient. Looks like we're just waiting on one more, waiting on our final panelist. So let me see. Okay, well, we're going to go ahead and get started. So I'm going to allow Brett and Brett to kick us off here. So I have with me for this panel, the topic is it's how UP utilities are getting EV infrastructure ready. So we're looking to have a discussion around what developers need to know, who and when should they engage with their local utility, and what is the best method to reach out. So those are some of the high level things we're looking to discuss here. But I'd like to introduce, we have Brett Niemi, who is the Senior Energy Services Manager from WPPI Energy. We also have Brett French, who is a VP of Business Communications at UPCO. And we are waiting for Mike Heiss, who is the CEO of Cloverland Electric Cooperative. I do see that Ali from his team is on the webinar right now. So, we should hopefully be able to get Mike on here in just a moment. Hopefully it's not a technical issue. But with that being said, the format, we're going to do a few minutes for each of the panelists to introduce themselves, their organization, what are the regions you cover, right? Because obviously there's a lot of utilities in the state of Michigan, some big, some small. So if you can kind of help us with those three things to get us started. And then from there, we'll go into, our panel discussion. So Brett Niemi, I can see you're unmuted. If you wouldn't mind kicking us off.
Sure, more than happy to. Thanks, Tim. Well, as Tim mentioned, my name is Brett Niemi, and I've been with WPPI Energy as an energy services manager for 13 years. Since WPPI doesn't sell power directly to retail customers, there's probably a lot out there that they're not really familiar with our company's name, even though you may be living in one of their communities that we sell power through. But WPPI is a not-for-profit wholesale power provider that serves over 200,000 homes and businesses throughout Iowa, Wisconsin, and Upper Michigan. Our corporate office is located down in Sun Prairie, Wisconsin. And then overall, we have a little over 100 employees on staff. Our utility is what's called a joint action agency. And it was formed about 40 years ago by a handful of municipalities down in Wisconsin. Our current membership is up to 51 locally owned electric utilities. Going back to 2007, we started serving 7 members here in the UP, which includes 6 municipalities and 1 cooperative. And I'll note that out of the 51 member utilities that we have, we only have 1 cooperative, the rest of them municipalities. The utilities that we serve here in the UP, we have the Village of Baraga, the Village of Lance, City of Crystal Falls, City of Negaunee, City of Norway, the City of Gladstone, and then the Elger Delta Electric Cooperative, which is basically takes up the center third of the UP. Our corporate office, like I said, is down in Sun Prairie, but I'm based out of my hometown of Bruce Crossing over in the West Central UP. That's so I can have some boots on the ground and work closely with our member utilities and their customers. And I'm kind of the typical jack of all trades, master nothing. I pretty much help our utilities, our UP utilities, meet their expectations of their customers. I work with, I'm a key account manager. I work with rates and finances, capital planning, municipal ordinances, metering, distributed generation, energy efficiency program management. And I guess that as of late, EV charging systems. That's what I got on my end.
All right, thank you, Brett. Brett French, I'll turn it over to you if you wouldn't mind giving an introduction for UPCO.
Thank you, Tim, and good morning to everyone who's participating in the webinar. Very happy to be here today. As Tim said, my name is Brett French, and I am Vice President of Business Development and Communications with Upper Peninsula Power Company. I'm located in our headquarters out of the Marquette County area, and we serve customers throughout 10 of the Upper Peninsula counties. Generally, we have the westerly 2/3 of the Upper Peninsula, and we maintain seams with a variety of other utilities, some of them that Brett Nemi had mentioned, as well as a number of others. Happy to be here today, happy to participate in the conversation, provide you a little bit more insight into what UPCO is doing to help facilitate and enable the integration and installation of EV charging stations in our service territory. Tim?
All right, thank you. It looks like we're still, I don't know. Oh, looks like Mike is in there. He's under attendees. So Angela or Alicia, if one of you could elevate Mike Heise, H-E-I-S-E, to a panelist. There we go. All right, so that's working. Mike's getting bumped up here. So Mike, it looks like you're active, but we will need you to unmute and turn on your video if you are able to use video. So there we go.
Yes, we are. Yeah, I took my t-shirt off and my baseball hat today. So yeah, definitely got to turn the camera on. So, but thank you. Yeah, I apologize for that. I having a little technical difficulties. The laptop didn't want to behave today. So
it happens. That's our new normal, right? So
that's right.
So thank you for joining us again, Mike Heise, the CEO and President of Cloverland Electric up in the UP. So if you wouldn't mind just, again, giving a quick introduction of yourself and, the organization and then what territories you cover.
Sure. I, again, Mike Heise, I'm the CEO of Cloverland Electric and started Cloverland back almost 2 years ago. Coming up February here, I'll be there 2 years. So I'm a native Ohioan, so I know there's a lot of boo and hisses about that. I'm born and raised Buckeye, but don't hold that against me. But definitely, it's been a great 2 years. Cloverland Electric is an electric cooperative, and we serve the eastern portion of the UP, and which coming from Ohio. I remember snow back from the 80s, but global warming has played a good role in Ohio. We don't see much snow anymore. It melts pretty quickly, but up in the UP, we definitely get it and it's there to stay. So it is a little bit of a different environment, but we have roughly 43,000 meters, 35,000 members across the UP. And again, we're a cooperative that we report to a 9-member board of trustees, and take care of the electric needs for that end of the UP. And I appreciate the opportunity to be here today.
All right, thank you. We won't hold it against you. You're on the right team now, so that's all that matters.
That's right. That's right.
All right, so I want to kick this off. I kind of, when I started my presentation earlier today, I kind of level set on EVs and on Charging 101. I kind of want to do the same thing here with our audience on the current state of EV infrastructure efforts within your utilities. So please keep in mind here, you're all here because you have slightly different business models, right? Investor owned, cooperative, municipal, so on and so forth. So obviously there's going to be a little bit of a different approach for each of you, kind of working within your operating structures. Would you mind each taking a moment to share what type of utility you are? Just kind of reiterate, I know you've already mentioned it. And then how important is supporting EV infrastructure in Michigan's UP to each of your organizations? So we'll kind of do the same order. So Brett and Amy, if you don't mind starting out.
All right. Yeah, so as I mentioned before, WPPI Energy they're a not-for-profit wholesale power provider. And then each of our member utilities have the same setup. They're not-for-profit, locally owned utilities. Looking at the operating structure a little bit more, it comes back to governance. Each of our 6 municipalities are governed by their respective city or village councils, and that's their rate-making basis for the utilities. The Elger Delta Electric, our lone electric cooperative, is a self-regulated cooperative, and it's governed by its board of directors. So with that governance structure, our utilities are self-regulated, and they don't have to go through the PSC review process. So when we're doing rate changes and stuff like that, or implementing any new programs, it's a local decision process. Looking at the importance of EVs to our utility question, yeah, it's something that we find it's very important. We know that as the EV market continues to grow, integration of EVs into our system, it's not only inevitable, but it's beneficial to our customers, and it's something our customers are going to want. So we want to be able to serve that need. So really, the sooner we can get ahead of the movement, the better. We felt as a company it was important to start embracing EV technology in our strategic planning a few years ago. So we started getting our feet wet, and we put together a program that helps, the primary focus, I guess, would be to help support home charging with level 2 chargers and giving people options to manage their costs. So we started that. We have an incentive program that our utilities can work with to help lessen the burden for people to install those. So that's where we've been. On the utility side, we have one of our member utilities has already installed a level 2 charger for public use. And we have a few others that are in the process of doing the same. Then they also, a couple of those same utilities are looking to do the level 3 chargers too. I think that's something that we really would like to get our feet into. And then kind of another side of that is, I think, Tim, you had mentioned it earlier in your presentation earlier, is, zoning and ordinances and resale. Those are all things out there that we haven't really addressed yet. None of the utilities that we have any zoning or ordinances that really regulate EV chargers, or, if our customers wanted to put EV chargers in for themselves. So that's something that we're going to be looking at, and we find that important as we move forward. And then I think, I don't know if it was Tim or Eric had mentioned about resale. That's something that we recognize the importance of that, resale of electricity within our service territories. We're not really sure how to approach that. We've been watching it in other areas, especially in Iowa. I know there was a case where the local utility did not want a gas station to reselling their electricity. on a kilowatt hour rate. So nothing that we see as a stopping point, but it's something that we need to address or at least talk about with our governing bodies.
Okay, thank you. Brett French.
Yeah, so UPCO is an investor-owned utility, and we fall under the jurisdiction of the Michigan Public Service Commission. Unlike the municipally owned or the cooperatively owned, we actually have to work closely with the commission and other stakeholders to receive the authority to do different things with rate structure and provisions of how we serve and support the customers that we have. With that said, we've actually assembled a team and have been working internally to look at a couple of questions or topics that will help our customers with their efforts to install EV charging stations. And we too see generally electrification, more specifically EV charging stations, a very important aspect of the role that we play and the service that we provide to the communities that we serve. With that said, the areas that we focused on largely internally with a team fall into two different buckets. On one hand, we recognize that we need to come up with tariff products and rate structures that are conducive to the installations that are being proposed by our customers. You've heard a little bit about level 1 and level 2 and also the larger DC fast charging. And when you take a look at the current tariff products that we have on the books, the rate structures generally they don't lend themselves well to the DC fast or the larger level 2 charging stations because they present a fairly significant demand component. And under the tariffs that we have that have been approved by the Michigan Public Service Commission, those demand charges start to add up pretty quickly, and they tend to make these installations less economically viable. And we recognize that, and that's an area that we are currently focusing our attention and performing some cost of service studies so that we can make some proposals in front of the commission and ultimately come up with a tariff product and a cost rate structure that is more conducive to these types of installations. So that's an area that we're working on internally, and I expect that you'll be seeing some filing activity from us in front of the commission in the foreseeable future. On the other hand, there's also the technical side and the engineering side. And I know that there have been some questions around the topic of can the grid support these installations, or what engineering and technical issues might need to be addressed to permit these installations to occur out in the service territory. And those questions need to be fielded somewhat on a case-by-case basis. And we are currently working with a number of customers proactively who have been looking to install charging stations, many of them municipal customers of ours. And we're working with them to evaluate the feasibility of installing the equipment that they're proposing to install, not just today, but also trying to account for their future plans. They may be looking to install 1 or 2 chargers today, and ultimately that will grow to be multiple chargers in the future. We want to be sure that our infrastructure and the distribution facilities that we own can handle that, whether you're talking about the transformers or the electrical devices or the poles and wires themselves. So all of that needs to be evaluated and taken into account when you're proposing projects. And we would encourage you to reach out to us and contact us very early on in your planning process so that we can, again, help to facilitate and enable success, bring our expertise to the table, provide you with the support that you need to succeed with the projects you're proposing.
All right, thank you. And Mike Heiss.
So again, we are Cloverland is electric cooperative. So we do report to, again, a 9-member board of directors, board of trustees. We work through, these type of issues. Again, I've only been here about 2 years. So one of the things, my background being an electrical engineer, I have been interested in the electric vehicle market since the Tesla first came out, and wish I would have bought stock back then on them as well too. But I've again, the engineer in me loves this type of a concept. So while I've only been there 2 years, we are trying to come up to speed now with a lot of the different things that have been mentioned already, as far as the charging stations, the rates around that. So we have retained a key accounts rep, and he has been helping me tremendously, starting to look at, and we've been reaching out to the state, starting to look at potential funds that are available for the installation of some of these chargers. As through some of the discussions we've had with some of the EDCs and the UP, you know, there is a growing interest. I mean, when I first got there, the big desire our members had was getting our power supply kind of corrected. We're working through that, but now a lot are starting to say, look, you know, this market is growing. In the summer, being in the UP, we do have a pretty substantial tourism industry where a lot of people are coming, and you know, the need for charging stations is starting to grow. I know there's been a couple in the St. Ignace area that have said, heck, we've got a lot of people stopping in wanting to park their Tesla, but they can't here. You know, so we need, you know, so it is a market that while maybe on the early end for the UP, and I think it's still some education to overcome as far as the big fear is how well are they going to work in an environment that you know, is colder and snowier than a lot of the population. So how will a car like this work? And so from that perspective, you know, there's still a lot of education around that. But again, we are very interested. You know, we are fortunate. We have two electric or two testing facilities in the UP with Continental and Smithers. You know, so we do have the desire to support their efforts as well too. Also looking at a you know, broadening the ability to have electric vehicles in the UP. So it is definitely on our bucket list of things we're working through to get educated on, because I do believe you know, there's a growing market for it, and there is going to be a lot of questions from our members that will come down the road of, well, how do we charge this? And to Brett's earlier point, how do I get billed for this? You know, the demand aspect of this can be pretty substantial. And in a market where, you know, buying and selling electricity, demand sometimes comes at a very big premium. So it is something to be very cautious on of how you price that. You know, again, being member driven, our goal is to never burden one member class and compared to another member class. So, you know, so there's still some education on our side, but, you know, we welcome any opportunity to support our membership, and, you know, continue to look forward to be, you know, part of the solution if we can. So.
Thank you. So obviously, you know, the four of us had talked, you know, prior to the panel, and one of the things I want to do is talk about, you know, potential like tariff options, right? And I'm looking at the questions that are coming in and whatnot. And so in the interest of time, I'm going to simplify the question I had prepared. And I'd just like to ask, you know, what do tariffs look like? What types of options are you guys bringing to the table? I know that there's like time of use. Like, can you help explain what that means to your customers, right? And what types of options you're considering, right? Knowing that nothing is kind of fully developed right now, but what can your customers kind of look and expect? And also, please take the opportunity, you know, some of your customers are on this webinar. How could they engage with you today, right? And that's open. Anybody who wants to jump in.
I guess I'll start. We're looking at a couple things. Nothing that we've really put into play yet, but a couple of things we're kind of bouncing around is, you know, maybe looking at maybe a low load factor rate where the demand charges are low rate. Another one is maybe an economic development rate where we start off with either lower or no demand charges for a limited amount of time, and then they come back into play. Another one that we kind of been really thinking about is where we'd be able to bring in real-time market capacity pricing, where it would be essentially from the wholesaler, us, WPPI, be a pass-through right to the consumer, where we could offer real-time capacity pricing. We've got a program that's similar to that for some of our industrial customers. I don't know if that's something that's going to be feasible or not, but just something we're trying to throw around and see if it'll work.
Okay, Upco or Cloverland?
I'll jump in. So we too are evaluating a variety of options, ways that we can structure some tariff provisions so that these projects can be more economically viable. Again, I think as we suggested and others have as well, demand charges tend to be the one aspect of them that can kill a project's economic viability. And to the point that Mike had made earlier, we too are very concerned that we're not creating a cross-subsidization issue where non-participating customers are having to pay a portion of the cost for those that are participating. So that too is a part of the analysis that we have to pay very close attention to. Time of use rates, as you alluded to, are certainly, one option for those customers that have the flexibility of picking and choosing the time of day when they're looking to utilize the charging equipment that may be installed. Another piece is possibly taking a look at the option that would exist between firm and non-firm to help manage some of the costs that would be attributable to having to arrange for capacities to support that. Part of the challenge with that, if these are public facilities or facilities that are generally available for public use as they're traveling through, they want the power to be there when they pull up to the charging station and plug in. And so it creates some dynamics that we need to be mindful of. And we're certainly exploring a variety of options through conversations that we're having with our customers, trying to better understand by listening to them, what their needs or what their expectations are for the equipment, for the service we would provide, and for the rate structure that we would be able to offer.
Yeah, and to follow Brett, we basically are in the same boat. Is the our power supply contract is unique, and capacity is at a premium for us. So when I look at our undertaking is very similar. I think we need to look at a cost of service study closer in order to really determine how we will do that. Because again, there's many different ways, as you mentioned, we could use time of use. I mean, there's many different ways we can get there, but at the end of the day, we still have to look at how that demand won't hurt all the other customer classes. And that's where we need to continue to look at it. Again, we're kind of in our infancy into the program, but I do see that this program, will continue to flourish. So it's from our perspective as well, that is something we need to get a better handle on as we are seeing more interest from our membership. So it is something we've got on our radar to start looking at is again, peeling out that cost of service. Because again, it's a unique problem. It's a great problem to have. More and more people want to plug in, which is a great thing. But ultimately, how do we get there and not cause an impact? That to me is the biggest key takeaway. But again, to your point earlier on as well too, if anybody has any questions, my door is always open. And also, we also have a new key accounts manager that has been doing a great job. He started during the COVID process, and so he's been doing a great job remotely as well too. So if there's any need afterwards, we can forward you his contact information as well. So if any of our members are on the phone and they have a question, they can always feel free to call me, or like I said, some of my staff as well too.
Yeah, and I'll just kind of say before the next question, I've been felt the warm welcome, right? As I reached out to each of you and your organizations to try and inquire about this event and your activities. You guys have all been very open in talking about this topic, and so I would again just echo to anybody who's listening, if you're represented by one of these organizations, please reach out, right? They're looking at this topic, they're interested in your feedback. Your feedback helps with the planning, right? So I'm going to kind of, take a topic that was just brought up. To me, it's the elephant in the room: demand charges, right? So obviously, these things can really impact the financial model for DC fast charging, which is a big part of the goal here. So what can you guys, first, if someone could just kind of take a layman's term explanation for the audience. Okay, this is what a demand charge is, and this is why it's important. Right? This is how it actually, impacts our ability to serve as the utility, for kind of level setting. And then, what might be feasible in the Upper Peninsula with your utilities in terms of trying to address that demand charge. So who can kind of just provide a quick, hey, this is what a demand charge is and why it's important.
I can start because I can point folks to our P1 tariff as an example. That would be the tariff that would be most applicable to these types of installations today. And if you're interested in looking at the details, you can find it by going to our website, www.upco.com. There's a link there that will take you actually to our tariffs and rates, and you can find the P1 tariff with all of the details and kind of work your way through the math, if you will, to figure out exactly what that may look like. It is essentially the maximum demand or the amount of energy that the device is consuming that is being recorded over 3 consecutive months. We take that number and the net number becomes a billing determinant as applied, through the tariff. So when you're talking about, equipment that generally isn't going to be used all that often or continuously, but when it is used, it presents a fairly significant demand. You're going to see a fairly significant demand charge, and yet you're not going to be consuming a lot of energy. And that's where the economic question that we've been speaking to previously becomes a bit of an issue when you're evaluating the feasibility of these installations.
Anybody want to add to that?
I guess quickly to get to your point of how I've always looked at the demand charge is, when you look at your bill, there's usually two big charges. You got your price for the kilowatt hour, which is the electron, right? The actual flow of the energy, and then the demand portion of it, which I've always looked at through deregulation, kind of came clear because really wasn't a big issue before deregulation is kind of that you're kind of buying that right to that iron that sits out there in the market. So from the demand perspective, that's the piece that we have to pay for that guarantees that somebody's got a generator spinning somewhere. And so whenever you plug that large load in, all of a sudden there's a significant swing in that demand need, so now where does that come from? And that's what typically is the challenge is the more and more of you have that, the more variability you have, it can really, create havoc, if you will, on managing those power supply costs. And so if your demand shifts around, it's hard to chase demands. It's sometimes hard to actually, figure out, but then again, they can be a penalty as well too, depending on the time of the market. And so, that's where this becomes more of an art than a science, is figuring out, how do you develop that rate? Again, going back to if now all of a sudden 20 people plug their car in and you now see a megawatt jump, did you now set a peak? And what do you pay for that 1 megawatt during that time frame? And then so that's where the more art than science comes into play, is how do you then frame up a rate so that, again, you are not taking the residential customers and burdening that cost, getting it more socially buried within the rates. And again, as a cooperative, that's the challenge we have, is we are also the rate making and rate decision. So, we have to answer to each one of those 35,000 members on what happens. So.
Tim, one thing that I would add too, and I think it's an important point because many of our customers may not be aware of this or may not be thinking about this aspect of the question. They may have an existing account and they may be currently taking service under the general service tariff and the provisions that are specified there. And they are actually, as a result, historically falling under the 25 kilowatt cap that is specified in the tariff. But then they begin to contemplate an installation. And when they add the additional load of the EV charging equipment, they find that they've actually shifted out of the general service tariff because they're no longer eligible for it, because now they're actually setting demand values that are something more than 25 kilowatts. So it's something that we want people to be mindful of, to reach out to us, have a conversation with us, better understand the implications of what it might look like if they were to add this equipment to an existing service, so that they don't end up with some surprises down the road that they just hadn't anticipated.
That's a really good point. So, Eric from Next Energy, our team earlier had mentioned, creating a separate line drop, right? A separate meter for that. So I'll kind of ask this question of, if I've got this business and I'm underneath that 25 kW cap, right? So I'm not paying the demand charge the way I would be if I'm above it, right? Is there an opportunity, if I want to install EV charging infrastructure, for me to separately meter that, and therefore that's a separate bill? And I'm not, then my electricity I'm using over here that's less than 25 kW won't be subject to demand charges that would be over here. You know what I'm saying? So I'm actually saving money, because if I put it all in the same bill, I'm paying the demand charge on that electricity I'm using over here too, which doesn't need to be. Is that something that can be done?
Possibly. And again, everyone's circumstances will be unique, and those are exactly, it's a very compelling reason to reach out to us and have those conversations so that we can work with the customer closely to determine what is the best approach for managing, what it is that they would like to do. Great question.
Yeah, it's definitely, sometimes, a lot of times when we're looking at services a lot of times it's better to combine the services. In some cases, like you just talked about, maybe it makes sense to separate them. You have to look at monthly service fees, how your coincident demands falls in place, and there's a lot of different situations. And like Brett had mentioned, is we're willing to work with the customers to figure out what's the best way to set it up.
Yep, and I've always viewed the demand charge, as utility is compelled to serve, right? But you guys don't always know when I'm flipping my light switch, which is a very small load, right? My air conditioner kicks on, which is a moderate load, or when I plug in, a DC fast charger, which is a large load, right? So if you don't know when I'm plugging that in, you've got to try to do your best to make sure that there's capacity to do that, knowing that that system is there and in play, right? So just to kind of provide that perspective for the communities or anyone who's looking to potentially, deploy EV charging infrastructure, that's kind of what your business model has to try to consider. So,
Tim, maybe a
Please.
bit of a segue off that, because I think Mike addressed the question very, very well in the context of demand and what you're paying for. You're paying for generation capacity that's available to provide those electrons on demand. But another significant part of the financial equation can be the make-ready costs. And those don't necessarily appear, or aren't accounted for on the bill, but rather these are costs and expenses that you need to anticipate up front. And the reason I bring it up, and I think Eric, spoke to the differences between single-phase charging stations, level 2s, versus, 3-phase charging stations, level 3s. Those costs, if you don't have 3-phase electric infrastructure near the site where you're proposing to build, could become relatively significant very quickly. And so there too, you're going to want to work closely with the utility to better understand what types of electrical infrastructure are readily available at or very close to the site that you're proposing to install the equipment on. And to what extent, are those make-ready costs going to become significant that you'll have to factor into your business plan?
And one other quick thing to add too, Tim, is coming from Ohio, right? I mean, the uniqueness of the UP market and why demand is critical for us is our worlds are different. People always ask me, what's the biggest difference I see up in the UP? And I say, typically you take the normal demand curve and you turn it upside down. So, I mean, if you look at it where I'm from here in Ohio, right? I mean, you typically see your electric demands are peaking during the day, and that's all year round. Your curve is a bell curve. So you have, very low demands in the winter, very high demands in the summer. And when you look at our load shape, you just take that bell curve and turn it upside down. And so why demand is important is because most people's methodology of an electric vehicle program is, works out great because when people come to home from work, they can charge it and they're kind of off peak. Well, when you look at where our peaks reside in the UP, because we are such a heavily in electric load, a lot of residential load, you look at, our peaks can be in the evening. So now it almost makes the problem worse when everybody comes home from work and starts plugging their cars in. It can add significantly to that demand. So why demand is important is because, again, the UP does have, the beauty up there, but it also has a unique environment where, again, our demands are shifted to non-standard hours, if you will, that ultimately, if you now start getting people coming home from work and plugging them in, that just compounds the demand that we've got to try to, keep under control, keep our costs as low as possible, managing that kind of unique environment we're in.
And that's a fantastic point, right? So part of the reason why we're here is because, we recognize the UP is a little bit different, right? So that's part of what we're here to talk about. So thank you for bringing that up. I do want to kind of shift to some of the questions that are coming in the Q&A box here. So question here is, do any of these utilities have a protocol in use to estimate if and how much their loads will grow as EVs build out over the years, right? So kind of, are you guys looking at, any sort of a model there? And then, how do you intend to meet the growth? Or kind of to your point, Mike, is it that you don't have the capacity you need to grow, or is it, hey, we're viewing this as an opportunity, we can structure programs to fill in the valleys, right, and kind of level everything out? So what would be the approach? You guys have models, and what would be the approach?
Again, from a Cloverland's perspective, we're new to the game, right? I mean, we haven't had much involvement. I'm new to the area, so that is our next step, right? Is to try to start looking, because I think along with that, there's other co-ops that offer incentives for people to start charging, right? They give them the chargers for free, or they give them a credit for the chargers. So there's a lot of programs I think that can come from it, but I think the point really is understanding the benefit or the value we can bring to the membership through that. But I do see that, yeah, I mean, if you just look at it as if all of a sudden tomorrow the gasoline engine didn't exist and everybody's plugging in, you know, that's a pretty significant hit, a pretty significant undertaking for all of us to figure out is, you know, how, are the wires big enough? Are our transformers big enough? You know, and then again, it creates a whole new world of how do we manage that short-term demand need? And again, being in that environment where we are. So it's a great question. It's definitely something on our radar, but I think it all comes from kind of a cost of service study, because we do need to look at what are those alternatives that, again, you know, the first guy that comes in and plugs in is probably going to have the easier time, right? Because it's not as detrimental to our load. But the more and more this becomes a reality, the more and more impact that is really going to have on our ability, or how do we manage that? Because if you don't self-generate, to your point, then you're going to have to fill in those gaps, and those gaps have to come from the market. And as we've all found out, how does that market react? And not to spin it a little bit, but you also start thinking about there's a big push on renewables, and renewables are very variable, if you as well. So, you know, so there's all, from managing electric utilities, a lot of dynamics that come into answering that question that can make that tough. Because again, if you look at, if we invest in solar, well, solar's not shining during the nighttime when people would be plugging their cars in. So do we have that as an opportunity? Maybe batteries are a fix. So again, that's the great part of being in this time right now is, especially being an engineer, there's a lot, it's a problem. And now we get to kind of figure that out kind of collectively here. So to me, I don't have a great answer for that yet, but it is definitely something that we do have to look at. Because like I said, at the beginning we haven't had a lot of requests for it in our territory yet, you know, but ultimately the requests are growing. And the more and more that there are out there, that yes, this will become a bigger problem that we're going to have to, and I should say problem, bigger opportunity, right, for us to solve. And really that opportunity is how do we manage that demand? And that's critical.
Yes, I'm going to take part of what you said. I'm going to give the others an opportunity to address this as well, but I also want to kind of add a piece here, which is, you know, we're early in on this with utilities, right? There's a reason for that. Okay, there's a reason we're still here talking about it. So, you know, Brett and Brett, as you guys, you know, kind of put your 2 cents in, tell me a little bit about lead times, right? So if we need new service, or we need to, you know, kind of address something in order to get these charging stations working, what are lead times like? You're talking days, weeks, months, years, like, so thank you. Go ahead.
Brett, go ahead.
Okay. Yeah, so lead times, you know, going from the level 2 to the level 3 chargers, really, it's a game changer in many ways for, you know, all the demand reasons we just talked about. But, you know, just getting the equipment, sometimes depending on what utility you're working with and the area that you're at, we might be looking to purchase a new transformer, depending on the size of what your system or your equipment is going to be. There can be oftentimes up to 3, 4, 5 months of lead time to purchase and get a transformer on site. That's not always the case. Sometimes we have spares, but, you know, you don't know until we are approached by the customer what we have to serve. And then also mentioned earlier, you know, these level 3 chargers, DC fast chargers, all the ones I've seen are require 3-phase service. Well, not all service areas within our, you know, territories have 3-phase service. So if you're looking at, you know, running a mile of 3-phase line where you have, you know, upgrading from a single phase, you've got construction times that you have to be sensitive about.
And I would add to that similar response. You know, the lead time, or the amount of time that is required for us to be where you need us to be to go live, or to turn on the equipment when you're ready to go, is going to be site dependent, and it's going to be project dependent. Larger projects, particularly those that would require the extension of 3-phase service where it doesn't currently exist, will require more time than if you're at a location where the electrical infrastructure is readily available and it has the capacity and the ability to support and serve the project that you're looking to connect. So the other piece too that I would say in terms of lead time, and I alluded to this earlier, we are currently, you know, working on some of the details of the proposal that we plan to present to the Michigan Public Service Commission more on the question of the tariff and the details that will be available. But that's going to take us some time. And we're evaluating different ways of approaching that question, possibly in a form of a pilot early on with a transition to essentially a more, a fuller program, if you will, or fuller offering as a part of a general rate case. And so, there are only certain points in time where we're in a position to be able to make those filings in front of the commission. And then, of course, we have the regulatory process and the time that's required to complete that process before we ultimately will receive a commission order that gives us the ability to move forward with the program that we're proposing.
Thank you for that response. So I got two more questions I want to get to. We've got about 7 minutes, so I think we'll need to move fast on both, but I think we can do it. So a question that came in is, it is my understanding that utilities have historically used nighttime and corresponding lower demand hours to cool their scale step-down transformers to prevent overheating for the next day. Will the utility companies, power transmission companies be able to respond to transformer needs? So do you guys see any potential challenges if we start to grow a larger DC fast charging network? Or maybe it's even hey, what we're talking about now, if there's 40 or 50 of these things spread across the UP, it's no big deal. Once we reach thousands, that's where it starts. So what? Maybe it's kind of a two-part answer there, but who can kind of help?
We take a stab at this first by saying that the distribution utilities like UPCO and Cloverland and the WPPI members all work very closely with American Transmission Company throughout the Upper Peninsula. They own and operate the high voltage electric transmission system to plan for tomorrow, whatever that might look like. And so we are constantly working with them through an iterative planning process to account for all of these different potential scenarios that ultimately might occur, that we all need to collectively as the electric utility industry be prepared to support. And they in turn also work very closely with the regional transmission organization or the Mid-Continent Independent System Operator, who ultimately has a responsibility for ensuring grid reliability and security. So there's a tremendous amount of work that goes on kind of behind the scenes, helping to connect the distribution level utilities to the transmission level utilities, to those who own generation assets, to those that are responsible and accountable for maintaining grid stability, to ensure that the types of questions that you're asking us right now don't become an issue in the public space. It just happens behind the scenes, and all of that has been essentially accounted for through good due diligence and good planning, good engineering.
But I think it's a great question, because I think the next step of Brett covered kind of more from the bigger picture. But if you now step down to the smaller picture and think about when a distribution company feeds residential loads, right? We don't always put one transformer per one house. There are times where maybe you have one transformer that feeds 2 or 3 homes. And now if each one of those homes decides to put in a charger of some level, now, again, it may create, a larger renovation, if you will, of the distribution network as well, too, because again, it really depends on how close your current system is to its maximum. So what's going to happen to the lines that are running down your backyard? Are they big enough if now every house has to have its own transformer? It's really becomes an impact question that really goes more to how widespread will it be? Because initially, again, 1 or 2 here or there isn't going to have the problem, but again, the more widespread it is, then that's a great question of yes, it's going to probably create a larger demand on the engineering side of things to really look at, make sure that that those distribution lines are sized appropriately to handle those loads as well, too.
And so what I'm hearing here is, more conversation will be helpful in figuring this out for all parties, as we move forward, right? So, because there's a lot of different ways this can go. No, it's not a one size fits all. Every site is unique, right? So again, that's part of why we're here too. Conversation. So, all right, I got one more question, and I'm gonna have Brett Nemi kind of kick this one off. So earlier we heard my colleague Eric McDonald talk about some of the things everyone should know before they break ground on an EV charging infrastructure installation. Are there any of those topics that you would like to reinforce, or any additional ways that the utilities can help maybe save money on infrastructure deployments for EV charging, so on and so forth. So kind of what would be, your pitch to those that are looking to deploy in your area?
Yeah, really, it starts with the conversation. The more that we know the needs of what you want, the better we can serve you. So, the conversation of where you're going to be siting things and, timing, that kind of stuff, we can better plan to work around those to drive costs down if need be. There's always more than one way to approach every project. And the more that we can have those conversations with the customer, the better we can figure it out together.
Appreciate it. So in 2 minutes or less, Mike or Brett?
Mike, go ahead.
Yeah, I would just follow Brett. I mean, that basically is, I think, key right now, because again, most of us don't have a well-matured program to a point where we have definitive things we can point you to. Conversation is the best way. So if you have a need or a desire, if there's something, that's really the best way that we can work together, is if you are looking for an opportunity to put a station in, then we just need to work collaboratively to figure out the best way to get there.
Brett?
The only thing I would add, it really helps our technical team, our engineering staff, if you're able to come to us some good details of what it is that you're proposing to do. And I know that if you're early on in your planning process, you might not know what charging station or what size of charging equipment you're looking to install. But if you're able to do a little bit of research and reach out to us as you're working your way through those questions, we can provide some very meaningful feedback to you that will help to develop your project.
Yeah, because as mentioned before, COVID has not been a friend of ours either. Delivery times are terrible. So when you start looking, I mean, we started earlier this year ordering our allotment of transformers that we need for next year, just because the lead times are terrible. So there's, right now is kind of a real bad time. So if you came to us and said, yep, we need this and we need a special size transformer or special voltage or, special design, maybe that transformer has to react to, those lead times could be 6 to 8 months, depending on what we're looking at. It's the markets, the construction, the availability is really poor right now, and delivery times are terrible out there.
Yeah, and then I don't want people to lose sight of the fact. So we talked a lot about lead times, right? No, talk to us early, because I think Brett and Amy, you were the one that mentioned if I need 3-phase power for DC fast charging, if I don't have it and I have to run a mile of that, that's lead times, but it's also cost, right? So if there's 2 potential sites that are being evaluated by a community or developer, the difference between whether or not you need to do significant upgrades on the utility side could be a major contributor to how fast the project gets done and how much it costs, right? So I'll just kind of leave the listeners with that last thought as well. I'd like to take a moment and thank all 3 of you for joining me. Really appreciate it. I think it was a great conversation, very useful for the audience. So thank you so much for your time. I'll let you guys turn off your cameras and relax for a minute. I'm going to go ahead and while we're getting things queued up in terms of the presentation, I'm going to go ahead and start to introduce Julie Staveland from EGLE, so the Department of Environment, Great Lakes and Energy. So Julie is the manager for sustainability at EGLE. I see Julie. Can I hear Julie?
Can you hear me now?
I can hear you now. All right, perfect. So.
Sweet.
All right, Julie, the floor is yours. Thank you so much for joining us. And please tell us a little bit more about Charge Up Michigan.
Awesome. Thanks, Tim. Good morning, everyone. I guess it's still before noon, so I can still say that. So as Tim said, I'm with the Department of Environment, Great Lakes and Energy, or EGLE, and I'm in the Energy Services Unit. I am the current State Energy Program Specialist, kind of jack of all trades for our office. So I'm happy to be here to present about our Charge Up Michigan program. So I'm gonna make sure I know how to do this. So I apologize for any technical difficulties. My internet is super slow, by the way, too. So what is Energy Services? Kind of a little bit of background on who we are. And I'm sorry.
No worries. It takes a second to sync. I was using the up and down
Okay.
arrows on my keyboard. So.
Okay, that's what I was trying, but it wasn't moving. So I was like, oh, is it my internet that's too slow? So, okay, So energy services, we're this designated state energy office. We get most of our funding from the Federal Department of Energy. We do have a combination of federal and state funding. So some of our state funding we use for a variety of programs throughout the state. And some of our funding that we also get comes from the VW settlement funding. And so our main goal is to kind of help promote healthy communities and economic growth and sustainability through energy efficiency and renewable energy. And that encompasses EV chargers. And so as Dr. Gamami presented earlier, the whole question is what comes first, the chicken or the egg? What comes first in terms of charging is the electric vehicle demand or the charging infrastructure. So we funded that study to look at, what would it look to create, what would a bare bone structure look like in Michigan for the EV infrastructure. And so as a result, we came with all these nodes and we identified, what that would look like to create that outline and provide worry-free travel for our electric vehicle users throughout the state. And so as part of that, once we identified where those nodes would be, we looked at, okay, well, how are we going to fund those, right? Because everything costs money and nothing is for free. And so as part of that, we came up with the Charge Up Michigan program. And so the Charge Up Michigan program is a grant funding program that helps for the installation costs. And so as our prior presenters were talking about, there's a lot of the make-ready costs, the lead time costs, there's the installation, and then the equipment itself to run and operate. And so for the VW funding that we have, we came up with a 1/3 model. This is kind of the base model. We know that this might not work in every situation, but this is kind of the base that we start with. So 1/3 of the cost will be covered by the state through our grant funding, 1/3 by the utility, and 1/3 by the site host. And so for the Charge Up Michigan program, essentially we want you to work with your utility first, because that is the very first step, because we know that there's a lot of things that go into that before we can even install the charger. So once you work with the utility, you find the site, it's going to work, then you apply to the Charge Up Michigan program, and then that goes through a whole review process. And then once awarded, you install the EV charger, and then it goes through a reimbursement process. A lot of the times, especially up in the UP, we know it's a different case scenario than it is in the Lower Peninsula. So we're actually encouraging people, if you want to apply early, let us know that you're interested. We can kind of, work with you and help facilitate some of those conversations with the utility and see what pay structure would work for that one. So as of right today, we have 56 projects across the state that have been approved. We've got 17 that are actually online. And then we've got 13 more that are in the queue. And so these are across the state, as you'll see the majority of them. So the green dots are the nodes that were identified in the MSU study. The black are the ones that are approved and they're going through the installation process right now. The blue are the ones that are online, and then the pink are the ones that are currently in queue. And we're really trying to flesh out the rest of this model, and that's part of why we're working with Next Energy to help facilitate some of these conversations, so that we can figure out how we can get EV chargers in these other nodes. And then, the other thing that we're looking at too is, okay, now that we've got some of these installed, let's go back and reevaluate that study and let's see, were we right? Is the data that we're getting from the people who are using these chargers that are installed, does that validate where we thought we were? And what are the gaps? What are the holes? What areas that maybe aren't identified on these nodes right now, there's obviously some holes. So do we need to put some additional nodes out there and expand this even further? We do have some other programs that are available too that I just wanted to mention that we're working on releasing here in the near future. We've got Charge Up My Fleet, which will kind of be like a phase 2, and this is going to be working with municipalities that are transitioning their municipal fleets to EVs, and this funding would provide costs for the EV chargers for the fleets that they're transitioning. We've also got the DARE, the Diesel Emission Reduction Act grants that are coming out, and these look at replacing older diesel vehicle engines with more modern, cleaner technology. And then the other VW funding that we have goes for our fuel transformation program. And this is going to be a 3-year RFP that covers different segments, whether it's, airport ground transportation or transit agencies or barges, things like that, and transitioning those to cleaner vehicles or EVs as well. And so I jumped through that really fast, but I wanted to kind of leave it open for questions and provide any other information that I can.
All right, so definitely fast, lots to digest there. Thank you. So I'm going to try to, keep an eye on, what's happening here in the questions box. But I do have a couple questions for you as well. And so my first one is, you said Eagle is currently continuing to focus on finding hosts for all nodes throughout the state.
Yep.
What could our attendees do to help?
So I would say, probably give us a call, contact us, let us know that you're interested. The other thing that we're trying to help facilitate is connecting potential site hosts with potential operators. I think Tim, in one of your earlier, it was either you or Eric, I can't remember now, but you mentioned that, sometimes there's, you might have the site host, but you have a separate operator that'll come in, that'll actually, invest in the cost of that installing the EV charger. And so then there's agreement aside that we have been contacted by a couple different agencies that have expressed interest in expanding their access to the market in Michigan, that they would be willing to work with a potential community or a site host. They would cover the charges, but they just need somebody to say, hey, yes, you can put your charger here in this location. So part of it is just contacting us and reaching out and letting us know that they're interested so we can help facilitate some of those conversations and connecting them to other potential investor partners.
Okay, I think that's fantastic too. And actually that was a next question I was looking at. And the question was, what is the balance between identifying best locations to place the chargers and then, kind of being able to work with maybe third-party operators, right, and driving profitability. So it sounds like, Eagle's already got a list of interested parties. The biggest, challenge right now is finding sites to put them. And obviously, Eagle commissioned the MSU study. And so we're really looking at that as a model to start from, right?
Yep. And I did forget to mention, so one of the questions that came up during one of the earlier presentations was in regards to zoning ordinances. So one of the other studies that one of the other grants that we have is with the University of Michigan, and we had them actually catalog all of the zoning ordinances within the state of Michigan. And so we have that as a free database that's on our website. And what it does is it lists out all the jurisdictions, and if their zoning ordinances contain any reference to wind, solar, whether that's commercial or residential, as well as electric vehicles. So you can go in and you can scroll through and find a community that has a reference to electric vehicle and then reach out and, see what their ordinance says. We don't indicate whether it's, favorable, pro or against, but it's an indication that it's within the zoning ordinance. So that's available on our website as well. And I'm happy to send that link out too.
Perfect, right? You're tackling a lot of the questions I've got for you here. So, but I think that's fantastic, right? And again, a common theme that I'm hearing throughout this entire event is communication, right? So, yeah, I was actually going to try and tackle that at the end. I'm glad you did. Don't be afraid to connect communities with communities, right? To ask, hey, what's working for you, right? I think it's fair to say the state doesn't want to be in a position to say, this is the best, right? Here's the preference,
right? But
more so, hey, here's access to information, allow us to help you make those connections, right? Which I think is fantastic. So thank you for doing that. There was a question that came in earlier today. Are there any increased incentives available for UP locations since they will be less frequently used compared to downstate locations? So I don't know if you want to take a moment to try and give an answer for this one.
So what we're really looking at for the UP is it's going to be a case-by-case basis. We know that the initial plan that we had developed with the 1/3 structure, that might not work because the UP doesn't have the same incentives that DTE and consumers have, in the lower peninsula. So we're really looking at these on a case-by-case basis. So I would say get your application in and let's talk.
Yep, absolutely. So is there a deadline for applications to the Charge Up Michigan program?
There is not. We are doing this on a rolling basis. We've got of the VW settlement funds that we had, we could only allocate about 15% of that to electric vehicle charging infrastructure. So that left us with about 9 million, just a little bit over. And so of that 9 million, we've allocated about 2.7 right now for current awards. So we've got, still some funding left. And I don't know if we want to go back to the map that I had. From the map, you can see that, we've got a lot on there, and that's the 2.7 million, but there's still a lot of green out there, and we still have, over, 2/3 of the funding left. So I would say, it's not like tomorrow, but the sooner the better, because, as we get applications in, we're going to reserve that funding for those. And, the goal is to have this network done by 2030, which crazily is only like 9 years away now. So the sooner the better. And, we provide these updates on our website, and we're happy to answer questions as they come in. But no, there's not a current deadline for this program.
Okay. You said that there have been 56 projects approved to date in your presentation. Yeah. So I guess, at a high level, maybe not specific numbers, but how much funding is still available? 56 seems like a great start, a good number, right?
Yeah. So we've still got probably, I'd say at least 5.3 million left available in funding. And, of these sites, basically any green dot that doesn't have another color by it is open. So we've only got one installation in the Upper Peninsula right now. So the entire UP basically is open right now. We are trying to kind of adhere to the study that MSU did for us, where it identifies how many chargers per location, because we don't want to oversaturate one particular area while we still have gaps in the other areas in the state. So once we identify, once we get all of the nodes flushed out, then we'll look at expanding and maybe putting additional chargers at some of the sites that are already funded.
Okay, so would it be fair to say then that, a good first step would be for communities to download the MSU study and look at the various nodes that were identified as opportunities to see if they align with those nodes?
Yep, and we do have, I actually just updated this morning on our website. So this map is on our website, and if you just go to /Eagle, Michigan.gov/energy, sorry. And then there's right on the main page that we have, there's electric vehicles. You can go there. We've separated it out from the study because it's a study, so it can be a little bit intensive if you're not familiar with some of the language and the research methods and things like that. And if you're just really looking for the map or a list of the nodes, we have those pulled out and separated on our website as well, to make it a little bit easier to digest and at a quick glance see what's available.
Perfect, and that wasn't even coordinated, so I'm glad I asked. So is there a limit on how much funding can be requested from the Charge Up program?
So I guess I'm not quite sure of that question. So like if it's in terms of, say, an applicant who wants to apply for multiple sites, no. If you have the resources and you're going to put in an application for 10 nodes and you have the funding and the backing for that, then you would have 10 nodes worth of funding. If you're looking at, okay, if the project costs $100,000 and that includes everything, then I'm going to apply for $100,000. We want to have some outside investment. We want you to have some sort of stake in the game. So we try to at least have, some from the site host. I know that, the utilities have some rebates. They might vary depending on who your utility provider is. But no, the state's not going to cover it 100%. We'll be looking at some sort of cost share between the applicants.
Okay. Question that just came in. So we talked a moment ago about those third-party operators that are interested, but pointedly, are there third-party operators interested in the UP specifically? And would they consider installation and service of 3 to 5 units in different municipalities and across multiple utilities? So I've had conversations with at least 3 different people who, are interested in expanding to the UP. And that we've had separate conversations on. I've tried to connect them with a couple of communities that I'm aware of. But in terms of the different municipalities, that would be up to the third-party operator and if they would be willing to do that or not. So that's, again, the communication, the conversations that need to happen. But yeah, we definitely have interest. There's 3, if not 4, that I know off the top of my head. Okay. Yes, that's fantastic. So it sounds like, if you are a community or you have some property in one of these nodes, Maybe you don't have, you want EV charging there, but you don't have the finances to make it happen yourself. This could be a great option to try and get the ball rolling.
Yep.
Okay. So I think this is my last question, but is there a requirement on the power levels of the DC fast charger to qualify for this program?
So the study looks at a mix of both kind of the high tech and the low tech. And, you know, based off of what equipment is selected for that site, it offers, you know, a range of, okay, if you use this many level 2s and this many, you know, level 3 or the DCFC chargers, then this is how many will, you know, should be put in at this place. So we're primarily looking at the DCFCs for those fast chargers, but we have done some that are for the level 2. And generally what we do for those level 2 ones is they have to be future proofed to be able to handle the DCFC at a later date. So no, it's not just specific to one. We are considering other ones. And again, we understand that it might be a case-by-case basis for some of these locations too.
Okay. So I'm just taking another quick look through the questions here to make sure there's nothing we're missing. So some of these we're going to try and answer you know, kind of at the conclusion of the webinar here. We're going to go through some of these questions and provide a little bit more answers. So if anybody wants to stick around for those, there is some great, I'll just kind of say there is some great information being shared in the Q&A about what's happening in other areas, other communities in Michigan, that sort of thing as reference points. But I don't see anything else that's specific and can be kind of targeted towards you, Julie. So I'll ask, you know, Jim, our CEO, to hop back on, because I know he's going to give the kind of closing remarks, but I'll just double check because Jim usually has some questions. So let me make sure he doesn't have any questions for you before you go. So Jim, I see your microphone is unmuted, but your video is not on yet.
Yeah. Okay.
There we
okay.
go.
So I face and voice now. So yeah, we have, hopefully the, our utility panel is still online because I think we have a couple more minutes, and I think there's some good questions for the utility or the utility members, and we start to think about how do we experiment and how do we think about things a little differently to start to build out this network. One of the things that if I were kind of using a baseball analogy and about a baseball game with where we are as an industry for electric vehicles and where we are in regions, I think the EV industry is like in the second inning of a 9-inning game, and infrastructure in some communities is at the start of the first inning. So you know, one of the things that I think is really important is the state leadership and all the things that Julie and Eagle are doing to help build out this network and to get us started down this journey of worry-free travel with an EV across our state. So we really appreciate, Julie, your time and the Eagle program and how this is putting Michigan in a leadership position. We've, you know, at Next Energy, we've looked at what a lot of other states are doing, and you know, Michigan, in what Michigan is trying to do and trying to accomplish, we really are one of the leading states with respect to how we're developing EV networks and how we're supporting the EV industry and zero emissions travel. So we have, but we're still early. And so one of the questions that kind of continues to come up is, you know, for the utility partners is some short-term and some long-term things. And, you know, one is hopefully Brett's still online because there's a question around the difference between what are some of the, you know, the Tesla published rates and Electrify America published rates and what the retail price of energy is for UPCO customers. And, you know, how would we think about addressing this from a, what could be an experimental EV rate or an EV rate that could be passed on to a customer in order to make this a more cost-effective solution. So I don't know if Brett's still with us.
I am. Thanks, Jim, for the question. I guess my response is, and I take it back to some of the conversation that we had earlier as the panel, it starts with a cost of service study. So we're continuing to work our way through a determination of what the true cost is to provide service to these types of installations. And then we're working on the next part of the question, which is, okay, well, how does that get transformed into some form of a tariff product that we can present, propose to the Michigan Public Service Commission, work our way through the vetting process there, and ultimately receive the approval and authorization to charge that tariff rate. I know it's not a great direct answer to the question that's being asked, but it truly does start with the cost of service to provide that kind of support to those installations, so that we're not creating a cross-subsidization issue where non-participating customers are having to pick up part of the tab for those that are.
And this is going to have a question for all the utility panels. If I wanted to install a charging station and charge a customer $1 a kilowatt hour for access to the station, is there any rule or regulation that would not allow me to do that?
I can answer on the municipalities side and everyone cooperative. Right now, we don't have anything in place that would prevent that. And I did mention that earlier. You know, that's a challenge that I don't know if it's going to come up and be something that we have to work through or not. That's something for our governing boards we have to talk to them and see how they want to treat that. But right now, we don't have any in the 6 municipalities that we work with and then Elder Delta. We don't have any, there's no zoning, there isn't any ordinances that regulate, you know, resale of electricity with EV chargers. We do have some language in some of the ordinances saying that in our service territories, you know, our utility is the one that can only sell electricity in there. There's some broad language there, but you know, an EV charger that gets put in, our utility would be selling electricity to that EV charger. We haven't really come across how we're going to treat resale of that electricity.
And Jim, I would add, we too are evaluating the answer to that question. It's a great question. We would essentially be providing retail sales to the owner and operator of the charging equipment, and they in turn then would be essentially reselling a retail product. I don't have a definitive answer to your question here today, but it's certainly a question that we're evaluating as we work our way forward in the development of our program.
Yeah, and I'll echo, we're in the same boat. Again, it's still for us, the biggest driver we still have is making sure that it doesn't burden our ratepayers. I think people would be hard pressed if they charged $1 a kilowatt hour to get anybody to charge their car anyway. So there's going to be that happy dance of, and I think that was one of the questions, is how can somebody make a margin depending on what the rates are, you know, but ultimately, I guess to just answer that question, to put it more in perspective, if you think about, you know, we as utilities have to make sure that the electrons flow. And the big part of that varies is that, and I hate to sound like harping on it, but is that demand charge. And so if you think about the cost of new entry into MISO, I mean, that could be $100,000 a megawatt year. So put it in perspective and say, how many cars can I charge for 1 megawatt? And then think about that has to be paid by the utility to cover that 1 megawatt. So if I charge that many cars every month for 1 year, you know, the demand component is could be pretty substantial depending on the time, you know, and that's the challenge we all have is, you know, how do you determine what that rate will be when you plug that car in, and what kind of impact does that have on our pricing? Because again, most of us don't have generation that meets 100+% of our load where we can kind of control that demand cost. We are somewhat subject to the market, and the market has been, you know, favorable, but for how long? I mean, we just don't know, and it a lot of times that can come day by day. So.
All right. So I'm going to make a little statement here, not with respect to your answers, but other questions that came up from the audience, and a lot of it has to do with, you know, what's the makeup of generation for the utilities in the UP? What's the renewable energy mix? How are we making sure that we're not shifting the burden of, you know, gasoline emissions to other fossil fuel emissions from electric generation, and how our demand charges calculated, and certain things that are really kind of, to me, long-term issues. We really appreciate, I personally, from X Energy, appreciate those questions, because it really is, as I said, we're in the first inning, and we got to get to, farther on in the game as we look at some of these solutions like V2G and other applications. But I appreciate your time, and I appreciate your efforts here into helping build out this network and engaging with customers. I would just kind of like to wrap this up with before I do a wrap up, I want to give anyone else here on the panel, if there's something that we missed or some other message that you want to get out to the participants, take a minute before I wrap things up.
All right. Well, there's one question that that's still sitting in the Q&A that I'll just kind of take a stab at real quick, because I think it's relevant for those communities and others that might be looking to do deployments. And it's from Maggie, and she asks, what should UP communities be thinking about? She kind of points out economic development staff to prepare now to support medium and heavy duty EV trucks and logistics, right? So, excuse me. I just want to kind of make the comment. We've talked about the charging infrastructure. We kind of talked maybe about like personal vehicle use and long distance travel tourism, but obviously this market for medium duty, heavy duty trucks and that sort of stuff. There's an opportunity there for EVs as well. So I think, in my opinion, the biggest thing you can be doing is, again, having these conversations, right? Have them with your suppliers. So let's say you're a grocery store, right? And your logistics companies that are coming through, what are they looking for in terms of the future for their vehicles? Are they looking at a transition, so on and so forth? Medium and heavy duty trucks are going to require a little bit higher power levels in most cases, right? Because bigger, heavier vehicle, you're going to consume more in the standard mile right now, conventional vehicles, you're consuming more fuel per mile, right? The same is going to be true. You're going to have, consume more electrons, if you will, per mile when you're doing medium heavy duty trucking. So just be starting to have those conversations. So talk to the different entities, because if you're not going to own and operate the trucks yourself, who is, right? Have conversations with them, see what their plans are. These are all topics that are on the table as we look at how to build out charging infrastructure, maybe where it should be located to. So I just kind of wanted to take a quick stab at answering that question. Jim, I'll hand it back to you.
Okay. All right. Thanks, Tim. So, one of the things that we wanted to do this morning, and we appreciate everyone for staying on with us. This is one of the few webinars that I think I've attended where the audience participation really hasn't dropped over the course of 3 hours. So I think it's been a great topic and a lot of great information. Is that, we wanted to provide an overview of EV charging. What are the different types? What are different things that you should be considering about? So a lot of good information was shared there. Dr. Gamani gave a great presentation on what is the statewide network and what are some of the reasons and the data behind what they've provided. And these resources are available for everyone. Eric did, I think, a great job of what are some of the things that you need to consider when you look at, I want to look at a charging station. I want to think about installing one. But I also want to think that there's lots of information and there's lots of resources that are available. And so hopefully, when we started talking about this, we didn't scare anybody off. Installing a charging station is really no different than what you would have to do to think about, I'm installing a new HVAC system. I'm installing other, electric or, high power equipment in a factory or in a building. So it needs to be planned for, it needs to be, permitted and approved. And there's a lot of resources that are out there that are available to people to start to think about this a little differently. We really appreciate the panel discussion and, what the utilities are engaging in and how, the utilities are thinking about it. And lastly, Julie's presentation for, what are some of the tools and what are some of the things that can be leveraged from the state of Michigan. Again, we're in the first inning of this, and I think it's really important, that we stay engaged and that you reach out One of the things that I think about in EV charging and all that is there is no one size fits all. The world's not going to be blanketed with just level 2 charging stations or 150 kilowatt charging stations or whatever. You know, just like each building is can be thought about the same, each building is unique because each building has different things and different people inside it doing different things and creating different loads at different times of the day. And EV charging is going to be similar to that. Most of us are going to charge at home at night when the energy is available and is the cheapest. But these networks are going to provide opportunities for people to travel across the state, go from city to city, and look at how they can move from point A to point B to C, you know, with an electric vehicle. So, you know, continue to stay engaged, continue to reach out to your utilities. You know, utilities are great sources of information. There have been a ton of links that have been provided in the chat box and in the Q&A. And as we make this information available, we'll do our best to make sure that all of the links are published. I know we can do that from the Q&A. We're trying to figure out how to do that from the chat box. And if it was my problem to solve, it will be gone as soon as this webinar ends. But we have a lot of smarter people than me thinking about this to make sure that we can get this information available to you. So really appreciate everyone's time and effort. And I think there's no bad questions. There's no weird thoughts about this. I think everything is needs to be thought about and needs to be looked at as to how do we move forward. So we really appreciate everyone's time here, and I want to thank all the panelists and speakers for their time and efforts, and for the audience for some great questions and great provocative thoughts of how we can move this forward. So with that, thank you all very much.